What's going on, everyone? Good evening. It is January 2021, the 6th, January 6th, 2021. I've got some worrying news. The cat is dead set on getting up on the computer tonight, so hopefully I can stave that off. Hope everybody's doing okay. Lots of crazy news coming out of Washington, D.C. in the States. I'm sure that'll come up today. But I was watching that, looking on Twitter and watching some live streams on that earlier. And it does appear that there was one female protester, I guess is the right word, that was shot in the neck. And reports are that she died. Shot by the Capitol Police trying to break into the Capitol House. So crazy stuff going on down there. You got Biden making speeches, the president making speeches. So there's a lot of theater going on in the United States right now. Tonight we've got Babs, Space Pope, verse. Well, not really verse. They're going to have a conversation, is my understanding. It is more of a conversation. We'll see how it turns out. Verse Payge. So I'm looking forward to that, to see how things are going, or how things are going to go. But I don't know exactly what they're going to talk about. They just said, Bab said, hey, can Payge and I come in and talk on Wednesday? I said, yeah, sure. So we'll see. Hopefully that's interesting. Got a couple stories from yesterday we need to get to. Blue Marble made a response after a conversation I had with him about flight and Coriolis. So we can probably check that out, listen to that, and talk about his response, which was pretty dang interesting. And then there's a couple things. Let's see what else. Lots of conversations about the atmosphere rotating, that moon satellite footage that we didn't get to yesterday, and Flat Earthers sail to Edge of Earth hit piece, and whatever else comes up. Anyway. Okay, well, let's see. We've got a couple people in Discord, so why not go over there and see what's going on? We got sound out there? Everything okay? Yeah? Okay, good. What's up, guys? Hello? Jimbo? Can you hear me? Is anybody there? Well, this is a first. We've got a couple people in Discord. I don't know if they can hear me or not, but I can't hear them.
Mike Plus, I can hear you.
Oh, there we go. Hey, Jimbo. I thought I was all alone there for a minute. What's up, Jeremy?
What up? What up?
How's it going, guys?
It's going good. We've been killing them all day. I can't wait for Babs and Payge to get it popping here. Let's do this.
Yeah, I was listening to that with Xanic and the ideal gas conversation. That was pretty funny.
You missed what happened before that. I killed him right before that too, on the downward. Gas moves randomly in all directions, but it's moving mostly down. That's not random anymore.
Yeah, that gas in the atmosphere is doing a lot of stuff, isn't it? It's moving down, it's moving around, it's moving around with the earth. It's just amazing.
Even in a sealed container, say you had a sealed container of just helium, they'll say the gas is moving randomly in all directions, but then they'll also say in the same sentence that it's moving mostly down, which is it's now not random anymore. It's like they're double speaking in one sentence.
Oh yeah, there's definitely some double speaking going on there. You and I were in an argument earlier with a couple of people from Jem's Discord about the atmosphere moving with the earth. I thought that was pretty interesting. They came up with this supposed experiment, with a ball inside of another ball. This isn't the first time I've heard this. With smoke inside of the bigger ball surrounding the smaller ball, and then you rotate the smaller ball. And evidently after so long, the gas or smoke or whatever you put in there starts moving along with the smaller ball.
Yeah, that doesn't happen.
Yeah,
they're asking you to prove unicorns don't exist when they tell you to do that experiment.
Yeah, that's a ridiculous experiment. I mean, do you need to do it to know that that's not going to work? And I kept asking, asking him, hey, that gas is going to end up moving at the same, speed as the surface of the ball? Well, just do it. Well, instead of complaining, why don't you just go do the experiment and then tell us what you find out?
Yeah. If it could be done, they would have done it, and we would have seen it already.
Exactly.
But it can't be done. It can't be done, and we haven't seen it, and the shit doesn't exist.
Yeah, so that saga continues. I'm gonna keep hitting them with that because that's a fun one. They really don't have an answer to that. Fluid dynamics is the other answer. Just saying fluid dynamics, they think that clears it up.
Rocky asked a really good question earlier. He said, if Earth's atmosphere is spinning with Earth, when does it stop?
Yeah, exactly.
What's the height at which it stops spinning with Earth?
I've never heard a good answer to that.
Yeah, I didn't hear anything good.
And it usually comes up, the Kármán line comes up, and then they say, oh, what, you think at the Kármán line everything stops? I said, no, that's not what we said. We asked when it stops. When does it stop rotating with the Earth?
They did say one answer that was when the gas is out of Earth's gravitational field, wherever that may be.
Yeah, that's ridiculous.
So some random unspecified place up in the sky.
Here's the problem I have with this. This is stuff that you just have to swallow whole cloth. I mean, if the Earth were a rotating ball, the atmosphere would have to move with it. And I call it lockstep because that's essential. They've called it that before. I didn't make that term up, lockstep. It would have to move one for one with the ground. That's ridiculous. Yeah, how does that happen? Show me.
They somehow don't like that term anymore. My bad. Go ahead.
Why is it ridiculous, Brandon?
Well, you just think about it. When have you known gas and solids to behave together like that?
Oh, any type of a prop on a plane, or I mean, just wave your hand through the air and you'll take the gas with you. I mean, you're to make the gas move.
Do you have any kind of demonstration or experimental evidence that shows how this could be possible with a giant rotating sphere Earth?
Wave your hand in the air.
Yeah, that's not gonna cut it.
I did an experiment yesterday. I was in my car. I opened the window and I took like a Coke, and I just put it out the window, and it was following me. Conservation of momentum. So they're right. I think we got to give this up, guys.
Exactly. Yeah. So it's just a tough pill to swallow, Left Lane. I mean, I feel like I know how gases and solids behave, and that doesn't fit up with all of my life's experience that the gas surrounding a solid would move in lockstep with the solid when the solid rotates. That doesn't make any sense whatsoever. When you run outside, that's like, say, the wind around you will follow you as you run. If I spin in a circle outside, does the wind stay with me? Does it spin in a circle with me? Maybe a little bit, but there sure the hell would be wind, and it wouldn't be this perfect, ideal, mathematical thing that you've come up with.
Yeah.
Not that you came up with it, Howard. Taking it out on you, but it's pretty far-fetched to me. And show me a demonstration. Show me where we see this phenomena outside. Take me outside and show me this phenomena.
Yeah, I want to see the experiment with these balls and shit and these spheres of the air moving this. I don't know how many times you have to spin it. I'd imagine, I don't know, 1,000,000 years maybe. I don't think it still wouldn't go all the same speed after 1,000 years.
Yeah, it's just not going to happen. Stuff doesn't work that way. It just doesn't.
You'd have crazy wind shear speed as you went up off the ball.
It's ludicrous. That's where it gets even more ludicrous. Like, okay, let's give them that the gases that actually touch the Earth are somehow carried along as it rotates. Those gases then pull the other gases along with them, and they all somehow move at the same speed. Like if I took a column out from the Earth of air, and I could just go up in that column, let's say there was no wind. I could go up in that column, and all that air is rotating perfectly in sync with the ground below it.
And if it was, Brandon, how would you travel in the opposite direction against it? Like at 1,000 miles an hour, for example, at the equator.
Well, that's the other thing. Then you got to add that on top of it. There's wind going this way. There's wind going that way. And I say, well, it's all rotating. And then you add the wind. No. Prove it.
Fantasy, bro.
Prove it. because that is like somebody told me that they have a pet unicorn. That is crazy. Anyway, so
Well, no, go ahead.
There's another thing too. That we can take away from them. If that happens, right? What happens to the magical Coriolis?
yeah, well, you add that Coriolis on top of there, and then that gets confusing too, because you're like, well, if it's moving in lockstep, then how is there Coriolis?
Exactly.
And that's what I got Blue to admit, that flying over a rotating Earth within their model with this lockstep atmosphere, you couldn't tell the difference between that and flying over a stationary plane.
Well, I'm not going to take Blue Marble serious until he changes the name of that YouTube video of gas pressure without a container. That's just clickbait, and he's a troll as far as I'm concerned.
Oh, you guys haven't heard about Blue?
No, what?
Apparently, Blue is hanging it up. He's changing.
Y'all welcome.
Thanks, Rakia.
You had something to do with
Take
that,
a bar,
Rakia?
yeah.
You think I didn't?
I don't know.
Uh-huh.
Did you?
I destroyed that guy like 5 times. It started with the flag over the water. And finally, over a year, got him to admit that it was waves and it wasn't the Earth curve. So then we started in on that helicopter. He hates me. I mean, that dude physically hates me.
Oh, you're talking about those videos from the Discovery Channel or whatever that they faked curvature
Yeah.
and
Yeah, Blue was all over that when it came out, or when we were debating it, and I finally got him. You know, it's one thing, it's one thing. I finally got him to admit that it wasn't right, and then he, of course, then said he never said that. So, yeah, I got him on the hell, but I've got him on several things. He's something, man. He's one of those ones I don't know. Like, he's either something's going on with him. You know what I'm saying? Like, it's too hot and heavy.
yeah.
I think you
they all
realize
work
that.
for NASA or something, or they're all just Masons or just science geeks or whatever.
Well, a lot of these
Did
guys
you
are
see that?
either
You know that-
former military or they're retired from the industry or something. It's just, I don't know if that's a coincidence that so many of them have similar backgrounds like that, or if there's something more going on. But I find that pretty interesting.
Evening, everybody.
Hey, what's up, Ranty?
What up, Ranty?
So,
Hey, I'm catching up with the news, man. What's going on in America?
yeah,
All hell broke
we're
loose.
about to talk about that actually. But before we get into that, I just wanted to show what Rakia was talking about, which was this stuff from it was the Discovery Channel, where they basically faked curvature in a couple different ways. Let me see if I can find the exact thing. So there's this one right here where you see the helicopter go up. You guys probably can't see it in Discord right now. Helicopter go up and helicopter go down. The only problem is when it goes up and when it goes down over the supposed curve, the same exact birds fly past the camera in the same exact way. Isn't that an amazing coincidence? So that's a funny one. And then there's this one where the bottom red stripe of this target, which I assume is what you were referring to as the flag, Rakia, is supposedly hidden by the curvature. The only problem being you can see the horizon and the water behind the target. Now, you would think, being as there's curvature everywhere in the world, supposedly, anywhere you go, you can't get away from curvature, that they would be able to, for their documentary where they're going to prove that the Earth is a giant ball, be able to go out and film some curvature. But here they are, faking it twice.
I could have gave them better pictures and places to go than that.
Yeah, no shit.
I think the helicopter also, when it came up, when it went down, it had the doors off, and when it came up, it had the doors on, or something like that. I've seen a video where it debunked that, and something about the doors to the helicopter were off in one shot and on in the other. So it was definitely manipulated.
Definitely some amateur stuff, for sure.
And they said those people were not scientists, like they were just 2 random girls they got off the street. And then, supposedly they were both scientists or whatever, worked for NASA.
The thing is, if you're doing shit for real, there's not going to be continuity errors because that doesn't happen in real life. Like you're not going to have the same birds going by this 2 different shots if you really did it, because the chances. What's the chances of that happening? Same exact bird, same exact spot, or the doors being open and the doors being closed. Go ahead, Lemon.
Half of it's studying their camera tricks, the studying the lenses and the camera tricks they use to add curvature. But you were saying?
No, I was good. I'm good. Is Payge and Babs doing this thing, or?
Hopefully, let's see if Babs is in yet. I don't see either of them yet, so we'll give them a minute. I don't see any messages from them, but we can talk about what's going on in DC too. Sorry, I didn't mean to go away from the subject on you there, Ranty. So yeah, pretty crazy stuff. I don't know what you guys are hearing over there, but there is a woman who was supposedly killed by the police breaking into the Capitol building. And I did see the video. She was definitely wounded, in dire need of medical attention. And there was some firsthand accounts that she has been, that she's died. I don't know if that's true or not, but that's what the word on the street is.
So is this kind of like the start of what you call patriotism over there, just sort of like backing Trump now? Is this what it's going to be like for the next couple of weeks?
I mean, our system of democracy is falling to pieces over here. It's pretty clear that there was some kind of weird thing going on with the voting for the presidency. You had a record number of people voting. You didn't get that when Obama, the first black man, or Hillary, the first woman, was running. It's just weird.
And also, you have the Antifa infiltration. They're saying that these are, redneck patriots, but one of them's got an Antifa tattoo on his hand, like they're Antifa agitators. So it may be a mix of, the actual, protest by people who are trying to stop the steal, and the Antifa thug agitators just trying to burn down America and start civil war. So it's really hard to know what's going on with this whole thing.
Yeah, absolutely. Is it all theater, or is there something more to it? But you can see this video here. People are climbing the walls. They were literally breaking into the Capitol building and got into the Capitol building where the Senate meets, I think.
Yeah.
The whole thing. They have pictures of them in their desks with their feet up. They have a picture of somebody in the speakers. Where they talk in front of the chamber. They were everywhere.
Yeah, I'm calling it. Those are Antifa thugs. They're the same unruly mob that you see in most revolutions. This is Soros. The conservatives outside, usually know how to act better than this, and most of the time you get violent revolution from the left. I'm calling it.
You think it's?
I'm with that.
Agitators faking being Trump supporter? I wouldn't be surprised. Who knows? This guy's a pretty good.
That's what I would lean towards without a lot of information. That's what my gut feeling is. And they just got the crowd all riled up. The agitators riled the crowd up, then they storm the Capitol, and whatever happens, right?
Well, that's the issue. Storm the Capitol. How is that possible? We're talking about 2021. We have all these people protecting things. Storming a Capitol. I already find that to be a little fishy myself.
Yeah, they just let them get in a window. Where are the where are the police? Where are the guards? Whatever. But it's probably staged, or at least they let this group in and let certain things happen. They control everything. Don't worry about that. They're in control.
If a lady got shot in the neck, was that their only bullet that they had, or did they miss all other times, or what? It does.
And it was a
fishy.
woman. Right?
Yeah, why would you just shoot
America?
one? Yeah, why just shoot one person and then let them overtake the Capitol building? Don't you keep shooting, or maybe it's just me? I don't know.
Yeah.
The whole story's funny, but not to expect something like this to happen when all this is going down, and we understand what's happening right now, right? In society, to not expect a theater play out right now would be kind of stupid. But what are they hiding right now?
One thing is for sure, right now they're having meetings, and they've already talked about this and planned it, how to spin this. They know what's going on. They know how to spin things. They'll use the media to spin it however they want to their advantage.
Yeah, and they've got whole buildings full of people whose job it is just to dream up different scenarios and how they can manipulate the public and how they can spin stuff.
Yeah.
Oh, yeah. You think the CIA is made of dummies? I mean, this
Think
is psyop
tanks.
stuff
Well,
that's been going on. For years.
yesterday I told the story about the spaghetti crop and how it was like a really big fake news from, what, 1957. They've been making fake news forever.
Well, the
I'm sure
thing
they've been
is,
doing it since. Go ahead, Lemon.
well, the CIA and Antifa are basically one and the same entity. They're controlled by the same international, interests that don't give a damn about America and are more than comfortable seeing America fall. So I wouldn't be surprised if they allowed them in there. I just read something on Twitter saying that there was a request denied to deploy the National Guard to the Capitol. What the hell is going on here? Are they interested in?
As a Canadian, I don't hate America, but it is a dangerous place and a dangerous sort of entity. And I don't mind this going through hardship and growing pains like it should. And I really am only thinking of how I'm going to make money later if there's an opportunity in the aftermath.
I was thinking about that too. As well, how's this going to impact the stock market? That's awful. Not that I have much money to put in the stock market, but I always think of that kind of stuff when these things happen. Here they are trashing some AP equipment, some cameras and stuff. It doesn't hurt my feelings to see this. I'll be honest with you.
Look, when they were busting in that window, they were using a police shield, How come? Where'd they get that?
Some of these guys are in tactical gear too, ex-military, I'm sure.
Police shield, I guess, carbon-made shield.
Well, these Antifa thugs are very dangerous. Like, people don't hear about the Antifa side of it. They're like peaceful protesters, but they bring weapons, they bring knives. They'll freeze a Coke can to make it a hard block that you could throw at people. They'll throw, stuff at the officers and stuff like that. These people are dangerous.
Oh, Antifa's no joke, for sure.
Breaking the windows and doing that shit now, they're not Republicans and rednecks. They don't act like that. They don't behave like that. These are Antifa and paid, Soros people, agents, whatever you want to call them. And they look exactly like the Antifa mobs, and they're breaking windows in Portland and everywhere else.
Mm-hmm.
Looks like the same spirit, the same people, and it really is.
Don't forget to give credit to what someone said in here earlier. Is a lot of people will fall in line. So it only takes a few people out there, 2 or 3, that want to cause a distraction, want to do all this mayhem, and then everybody starts doing it with them. That's society now. That's what they have literally indoctrinated people to do, and it's sad.
Oh yeah, you break a window and climb through it as a group, other people are going to follow you, even though they don't even know why you're going in there. That's just human nature.
Exactly.
And with these protests, they'll start out peaceful, but all you need is one agitator to just light the fire, kill somebody or hurt somebody, and it just spreads. It's a wonder that it didn't turn into some sort of violent thing.
Yep. Yeah, so I think this will probably be some drama for a couple weeks. And who knows how they're going to take advantage of it. I think that was a good point. Are they going to ramp up more censorship? Are they going to, who knows what they're going to do? But yeah, I don't think anything good is going to come out of this. I got to be honest about that.
Well, of course. And I think it's a little funny how they're already, this is what they do though, they're already throwing it on the UK news, right? Making a mockery. They instantly throw it over there for all of them to pay attention to what's happening over here too. Like the UK don't have enough to be worrying about?
Well, once America falls, they'll get their socialist nightmare. And so people don't even care if Trump legitimately won. They're just like, get him out of there and get us back on the track for globalism and the dissolution of America. They talk about how these socialist parties go right back to China. They're funded by China, and they go right back to China, even with some of these, supposedly grassroots voting record efforts that target felons, that target minorities, and try to get out the vote for the leftist Democrats and stuff. This whole thing is just, smoke and mirrors. And even the BLM founders are all trained Marxists. They said that, we're trained Marxists with Alicia Garza or whatever the hell her name is. And so there's, a big veil over what's really going on here.
Unfortunately, it looks like our debate has fallen through. Something with some kind of scheduling misunderstanding. So no debate, but that's okay. We can talk about other stuff.
Sure.
Who backed out? Because I'll take somebody's spot.
You want to debate against Babs?
Yeah, I'll go against Babs.
Okay. What are you guys going to debate?
I'll take Babs on in anything.
Really?
Oh, go ahead. Let this other guy let them do it. Because I'm at work. So
Rob, you want to debate Babs? Was that you, Rob?
I will definitely debate Babs. I am at work right now, but I will definitely debate Babs in anything.
Well, yeah.
Anytime when I'm not working.
Okay, so you're not available to do it right now. So, Jeremy?
Not right now, but I just want to let you know I will debate Babs on anything.
Yeah, okay. Cool. All right, well, let's see what else.
all right.
Hold on, sorry, I'm messaging
I don't know
him.
what Babs' point. What did Babs want to debate?
I don't know.
He's fighting for gravity right now.
I told him to come in. I don't know what their deal is. Gas pressure or
Yeah,
something.
can you hear me?
Oh, there you are. What's going on, man?
Yeah, what's good? Yeah, so it wasn't my fault. She got her days mixed up because they're in a different time zone. So she thought that Wednesday was next week. And that really sucks because I was hoping it was going to happen today. And about...
She said earlier.
What?
No, I know her.
Yeah, I saw her in chat earlier.
Yeah, she's an Emmer's server. You're probably talking about the other page, not the one that I was supposed to debate today.
Oh wait, I didn't know, but there's two pages.
Yeah,
there's two different pages. Yeah, but yeah, I'm really sorry about that, Brandon. I thought she knew what was going on. Apparently, she didn't know what was going on, and now she wants it to happen next week, Wednesday, because she's saying that she's not prepared enough for me. Why do you need to prepare for me, though? It's just me.
Question for clarity: which page are we talking about? The Australian page?
I think they're both.
There was two pages.
I think they're both Australian.
Oh, great!
The page who's regularly on the page who's regularly
the page
on
with
the show.
The page with a German Shepherd.
The page that we know, right?
Page.
Yeah.
Yeah.
Okay. Cool.
Yeah, the one that we know, the one that's got the Alsatian dog.
Well, we know the other page too. Shout out Page in the chat, but page 42. But yeah, the one that's on the show on a regular basis. So next Wednesday, you guys.
Yeah, but I get it, Paige.
Debate.
I mean, I understand. I understand why you're scared of me, Paige. But I was going to be nice to you today. I wasn't even going to be the normal me. So I'm kind of disappointed that you backed out of this.
Well, what were you guys debating today? What was the topic?
Gas pressure.
Oh, interesting. There ain't much probably to debate about that, though, right?
Ooh, gas pressure. Are you trying to say that it?
I would tear your ass up on gas pressure, Stacey B. Don't even start.
I know what you're thinking, sweetie.
So you're trying to say it's caused by gravity, or what are you trying to say about gas pressure?
Mm-hmm.
Yeah, it's caused by gravity because gases have weight.
How do you weigh a gas? You already know I got you in that one, Bab.
So now
You
we're
got
going to
me?
the gravity container.
Oh yeah, you did. You did say you got me. How'd you got me, Jeremy?
The sides.
The sides of what?
The side. Where's as far as the dome goes, you could get past that, but the sides of Earth, you're gonna need some kind of containment for that.
What do you mean by the sides of Earth? Earth doesn't have sides.
Well, I mean, if you think it's an infinite plane, then I guess so. Eventually, you're gonna go, and it's gonna come to an ending point. No, you're gonna need some kind of containment.
It doesn't have like sides or a container of any of that. You guys can't prove that there's a container. You can't prove any of that.
We can prove gas pressure can't exist without a container, and you can't prove that in reality any other way. So what are you trying to say here? Can you
But
show me
What I'm
that?
trying to say is that you've got gas pressure mixed up with atmospheric pressure. With gas pressure, yeah, you need a container to have gas pressure, but atmospheric pressure is a result of gravity.
But the thing is, are you
Uh,
saying that gravity pulls to the center of a ball, or what do you mean by gravity? Because as flat earthers, that's not going to work if the land is flat.
Correct.
It could still.
Based on the globe model, gravity pulls to the center of mass, and every mass has a center. So even a flat Earth would have a center of mass. But if we're dealing with an infinitely scaled, infinitely sized Earth, then you don't know where the center is. Can anybody point to me where the center of the flat Earth is?
Babs,
Can
you
anybody
can
do that?
Pillars
No,
on
you
top
can't.
of a watery deep, so it may not be this globe dough ball or whatever that you're thinking of. We need to see if there's a gravimetric center in the first place. Otherwise, it's just philosophy and theory. And if we're going to go with philosophy and theory, I'm going to go with the background medium of ether, giving us our gradients as to what rises, falls, or sinks.
So do you really think that? Do you really think we're on pillars on a turtle's back? That's ridiculous.
I didn't mention a turtle, but
Hey,
if you want
nobody
to use
said
that
that.
to make it sound ridiculous, the ancient accounts all agree on some level with flatland covered by some sort of dome covering on some sort of pillars, deep, whatever. I go with the biblical account that says it's on pillars on top of a watery deep, and say that that's pretty defensible since we haven't even drilled to see what's down there in the first place.
Babs, like I said,
Exactly. We don't know what's underneath us. We don't know what's under us. We don't know if their pillow could be under us. And furthermore, everything that has mass has weight, and everything that has weight exerts
But that's
pressure. So gases have weight, so they exert pressure.
But Babs,
how's that
what are you
circular?
Gonna do, what are you going to do with the edges when you come to the edge of the flat Earth? You're going to need some kind of containment there.
And also a force.
Well, why would the edges matter if it's mass attracting mass? Why would the edges matter? I don't understand that.
Mass attracting mass.
Well, unless it's an infinite
with magnetism. There are magnets that repel. Those are masses that repel other masses. Why are we even talking about gravity still?
What is your is that your position, Babs? That it's gravity is caused by mass attracting mass?
That is my position. Yeah.
What is your evidence to support the
Yeah,
mass
laugh
attracting mass?
all you want, but your explanation doesn't make any sense.
Huh?
Your explanation doesn't make any sense.
I don't believe in gravity at all, so I don't have an argument for gravity.
Wait, can I ask a question? When you said something about gas pressure is different than atmospheric pressure, you're still talking about pressure, right? It's pressing against something, a container, a wall. It's exerting pressure.
Yeah.
So when you try to differ the two, why are you doing that?
Because they're different.
How? It's pressure. Pressing on what?
Gas pressure is gas.
In existence. You're just claiming gravity.
What is it?
You have no understanding of gravity.
There are
man.
mountains
You have
of
no
evidence
proof
for
of it.
gravity. There are
So
mountains.
what, you claim it's a force
There are
now or
mountains
mass
and
attracting
mountains
mass?
of evidence for gravity.
What are you doing?
The problem with that is gravity asks the air mass to press on itself. So that's contradictory. You wouldn't have gradients with gravity like that. You just have a mass that's pulled to the ball with hardly any gradients at all, just a bunch of stuff that's pulled. That's kind of contradictory.
If the Earth was
Okay,
dense enough,
well, hold on, Lemon Bird. Why do we have a gradient in a container in a homogeneous atmosphere? By homogeneous, I mean that the atmosphere is the same concentration, meaning that it has the same compounds regardless of where you measure it from. If you measure it at sea level, you're still going to get the same compounds as you would on top of Mount Everest. So how can a homogeneous mixture form a gradient in a container? How can that happen?
One layer is pressing against another layer, pressing against another layer, all the way to the thing that stops the pressing, the container, aka the firmament, aka the barrier, or in the other direction, the ground.
Babs, have you ever seen a terrarium?
Yeah.
And there's things composting on the ground. You would agree there's a gradient in that, no?
Yeah, but those are things that are of varying densities. That's why they form gradients. The atmosphere is not of varying densities. It's a homogeneous mixture.
What? Wait,
Yeah, it is.
hold on.
Yeah, the atmosphere is homogeneous.
Okay, you're going up against Andrew Thomas Young on this one, but so just real quick, what reference at all can you take us to right now to demonstrate that?
Are you going to ask for citations now? Well, I don't have those. You can look for those on your own, though, and you'll find that what I'm saying is correct.
It's not my claim. What? You're a fucking baller, dude.
Are you a baller now, Babs?
Okay, listen.
Sure.
Okay, listen,
No,
Babs.
I'm not.
Listen.
No?
Babs, real quick, bro, okay? I'm not being a dick. You just said the
You're being a dick by calling me a baller. That's
okay, because you're acting like one, bro. Listen very carefully. Don't be a dick. Listen, you just said the atmosphere is homogeneous. Now, all I'm simply asking you for is, where can you point me to demonstrate that? And then you put the burden of proof back on me and say that it's my responsibility to prove your claim. That's what a fucking baller says to us. Okay, so man up and please go away for a minute. Find a citation, and then come back and go, here you go, Travis. This is a scientific document that shows that our atmosphere is homogeneous, which goes directly against the astronomical guru, Andrew Thomas Young.
Right. And let's get this straight.
So you're not gonna.
Just because,
okay, thanks. You're not gonna.
Are you gonna let me talk or not?
No, because I didn't ask you to talk. I asked you to go away for a minute and then come back with a citation.
Well, you don't do, Travis. I do whatever I want to, so don't boss me around, okay? And just to get things straight, just because I don't have a citation right now, this is not a win for you. I can get a citation if I want to. You know,
No,
I don't have.
No, you can't.
I don't have things.
No, you can't. I just looked
What
it
do you
up.
mean? No,
You're
I
absolutely
can't.
incorrect. You're absolutely. Wait, let me finish.
What do you mean? No, I can't.
I just looked it up. Okay. Would you like to go over it? You can Google it yourself. It's heterogeneous. I can't even say atmosphere, right? You're talking about only on ground level is the homogeneous. I can't even speak today now. But you're not speaking correctly. That's not true. You made a statement that all of it is, and that's not true.
Homogeneous versus heterogeneous.
Thank
But
you,
the
Damien.
thing is, if a force is containing, it's only powerful and sufficient if it makes everything go in that direction. There's air layers going in 90 degrees opposition to this gravity thing. And there's stuff that's going up against the gravity force. So the force isn't even sufficient. It's not even powerful here toward the surface where it's the strongest. So why are we even going with it versus something else like density or electromagnetism or something else that's more powerful and more able?
Right. So, you're saying that the atmosphere is not homogeneous. That might be the case if you're considering the different layers of the atmosphere, like the mesosphere. But I'm just talking about the troposphere. In the troposphere, the atmosphere is homogeneous. And Stacy, could you post your citation? Oh, there it is. Okay, I see it now.
Well, let's go with electromagnetism. That's all that I'm saying, because you can put an egg in water. It'll start floating when you change the density of the medium and put electromagnetic salt in there. All of a sudden, it starts floating. So that looks pretty convincing to me.
Sorry, I should have put the citation as I was stating it, and I will do that. I never see something that I don't back up, honey.
So, Babs, how do you reconcile globe gravity, which they tend to say pulls to the center of a ball, with a flat Earth? If you're saying, the Earth is flat or whatever, how do you reconcile those two?
Listen, if the Earth was
I just
dense enough
did.
and deep enough, if the Earth
I
was
just
dense
did.
enough, if the Earth was dense enough and deep enough, I don't see why it couldn't work like the globe gravity does.
So you think that there's
I'm not sure why you guys are even talking to him. Babs, go away. No. Go away for a minute.
Thank you, Travis.
Go away for a minute and just bring us a statement where you can justify that the troposphere is homogeneous. That's all.
As far as mass attracting mass, that is not with the spherical thing. Just mass attracting mass. It might be able to work on a flat plane if it was dense enough and thick enough.
But
'Cause
why
as
do we
far as
need?
I can
Why do
see-
we need this force to be attracted to the center of the Earth? That's a ball conception. I don't understand why that's necessary for any of the effects that we see.
Yeah, that's Neoplatonism, which says that force is pulled to the center of a ball. Why are we
Because
making?
he needs that force to pull down his gas without a container. Otherwise, he has nothing.
But it doesn't have to go to the center of the. I mean, what we see, the effects that we see on Earth, are things falling to the ground, right? They go.
Yeah, agreed. Yeah.
I mean, we don't see anything fall towards the center of the Earth. No one's ever seen that.
Like plum bombs, for example. If we were to hang them 2 miles apart, right, make a straight line in their la la land, we should see them like vectoring inwards, right?
Yeah, they say that, but has anybody actually ever witnessed that? Can anybody really say with any confidence that they've seen 2 plumb bobs that aren't parallel?
Oh,
Well,
No,
they
not at
say
all.
they do based off of curving lenses, though, and the angles are messed up in those curving lenses, so even that's unreliable. That's why I prefer to go with a laser traveling straight and true over the land. I mean, a lot of this is based off of what you think the shape of the land is. If you think it's a ball, you're going to go with ball gravity, but if it's flat, that becomes questionable.
I'm going to make a slight analytical prediction, and that is that mass attracting mass never existed as an explanation for why things fall until observations about what happens in the sky started to dictate what is believed to happen in the quote-unquote universe.
Absolutely.
Because the only explanation for what's going on up in the sky is for you to say, well, maybe they are attracting each other, and then you just start building your shit up. Okay, this is it, we're dancing around the same criticism, guys.
They're building their foundation in the sky,
and they're all conceptual.
With toothpicks. Well said, guys.
Yeah, and that was the power of Cavendish when they came out with that. It allowed them to tie Newton's stuff to an effect that they saw on the face of the Earth. That's why they called it the first great unification.
Yeah, and if this force isn't sufficient to curve the land, how's it going to be sufficient to curve or affect an air column? That's what I don't understand. I mean, I thought that they were already moving toward gravity fields, which sounds very ether-like to me, and basically talking about a field-like or medium of some sort. I'd say it's electromagnetic, determining what rises, sinks, or floats anyway. So why don't we just go with an electromagnetic medium that dictates the rules for what rises, sinks, and falls and gives you your gradient layers? Why not that?
Well, is there any evidence for it, Lemon? That's the part where I get caught up, and why I don't speculate on why things fall down is because I haven't been presented with any evidence that says it's what is the actual cause of it.
Because the closest I've seen is the egg in the water. When you change the density in the medium of the water, all of a sudden it rises and you get anti-gravity effects.
That's it. I don't know why we need more than that. Why do we need this other story? I've asked many times what the utility of it is. What is the utility of having these other stories of saying what the cause of gravity is? And it all comes back to like Travis said, they want to be able to explain what they see in the celestial bodies. It supports their model. That's it.
Things fall down when people drop them.
Yeah.
Yeah.
And I think they're trying to go with different directions so that they can make new experiments, maybe control gravity, have anti-gravity effects, or make a planet. But the thing is, if this stuff isn't stated properly, even if it's a just so story, it's going to guide the wrong form of exploration, scientifically and otherwise, and you're just going to go down a rabbit hole. We need to look in the right place, even with these just so stories.
Okay, so here's something interesting I was just thinking about. Shoot, what was it he said? Okay. Shit.
Well, while you're doing that, Jimbo, you're a little too close to your mic or something. It's real loud. Go ahead.
Okay. Just like we have separation of church and state, we should also have separation of science and state. Okay, but we don't. The scientific community dictates what all of us need to believe about science. We don't have these denominations of scientific groups that allow for multiple. So, Brandon, you just asked the question, and the first thing that I thought of was that we have a different explanation for creation in Christianity than we do in Hinduism, or that we do in whatever else you want to have, right? So we have these different explanations, and we're allowed to belong to one of those groups without infringing on, any other aspects of our livelihood. But when we get into science, you can't do that. So there's an aspect of that unification of state and scientific doctrine that, for some reason, you can't buck against.
Well, and they even talk about it in the same way that I would imagine a theocracy talks about their state religion. They'll say you're a science denier, you're denying science. They praise science. Science is endlessly praised. It's put up on a pedestal. It's almost treated as if it's untouchable, and that all of our decisions and all of our life choices should be guided by what they consider to be the one real true science. It is our state religion. It's almost a worldwide religion.
It's similar in that it promotes foundational thinking that can't be questioned. Religion does that too. With scientism, it says, you need to throw out this other religion because science has given us a better idea to replace what religion said that happens here. So I call it the replacement fallacy. The fact that science could replace what religion did in that regard kind of implies that they're one and the same thing on a certain level, because otherwise it wouldn't be able to replace what came before, like a puzzle piece. You take out one puzzle piece and put a puzzle piece that's exactly the same shape in there, and it'll fit. It's the same thing with scientism. I think what's happening now is you have a little bit of ancestor worship too, because they say you're standing on the shoulders of giants. Don't question what they did. That's ancestor worship, and traditionalism. What if they're wrong? What if what they said isn't correct? Do I have the freedom to question that or not?
Exactly.
Yeah, well said, Lemon. Geez, that was great.
So, I guess we need to figure out, religion or not, what is allowed to form the foundation of our life, our soul, and whatever we're doing as we're going forward into other areas of life, because that's just another form of fundamentalism at that point.
Yeah.
Well, they keep saying that science is ever changing, and every time I talk to these people, it's the same thing. We just have this little bit of evidence, and we might get a little bit more evidence, and then we'll change science. However, when we talk to these people about this stuff, they don't want to hear it, and that's the problem. I'm like, your science will never change. Your pseudoscience, as you call it.
Yeah, that's because they want you to continue to develop the idea that they have. They don't want you to go back and nullify their claim, right? Which is what we're doing. We're going back and saying, no, your premise is 100% wrong. Now, they're not going to care if we take their premise and then develop something else that's new. They just don't want anything taken away.
They don't want us to question their doctrine. They're sacred texts almost. They're almost like holy text, commandments in a sense, I don't know quite what the right word is, but they're these untouchable things that they won't allow to be questioned.
Sorry to interrupt, but I'm back, and I posted the citation that Travis wanted. So you can take a look at that when you have time. Now it's your turn, Travis. Where's your citation that says that Earth's atmosphere is heterogeneous? Where's your citation for that?
Well, let's take a look at your citation first, shouldn't we?
I already provided it earlier.
I'm driving. Babs, thank you. I'm driving right now, but I will take a look at that. Yeah, thank you.
Well, I'll read it. Examples of homogeneous mixtures, solid, liquid, and gas. In chemistry, mixtures come in two overarching categories: heterogeneous mixtures and homogeneous mixtures. We've covered heterogeneous mixtures, but what about homogeneous mixtures? Okay, so that's just defines it. Understanding homogeneous mixtures, solid homogeneous mixtures. Where does the relevant point come in?
I posted a screenshot underneath the link.
Okay, so this part right here many of the most common gaseous substances people encounter, including the most common one, air itself, are homogeneous mixtures. The air that you breathe is homogeneous mixture of oxygen, nitrogen, argon, and carbon dioxide, along with other elements in smaller amounts. Because each layer of the Earth's atmosphere has a different density, each layer of air is its own homogeneous mixture.
Right. Now, when they say air of the atmosphere, they're referring to either the troposphere, mesosphere, or the different other layers of the atmosphere, not the troposphere in particular.
Well, they're saying here because each layer of the Earth's atmosphere has different density. Is that how you took it? That they mean those big categories? Because they're said to be a density gradient. So is each step in the gradient a different homogeneous mixture?
No.
Well, it says density is the thing that determines. So is the air at the top of Mount Everest the same homogeneous mixture as the air at sea level?
Yes, it is.
It is, but they're different densities, aren't they?
Yes, they're different densities because density is mass per unit of volume. So if you have more mass in a volume, then it's denser. So at sea level, you generally have a larger concentration of molecules. That's why it's denser than on top of Mount Everest.
So if density is one of the factors that determines whether something is homogeneous, I would say that by that definition, no, then the air at the top of Mount Everest and the air at sea level are not the same homogeneous mixture. They're two separate homogeneous mixtures.
No,
density does not cited.
Density does not determine whether something is homogeneous or not. By homogeneous, I mean that the air on top of Mount Everest also consists of the same composition. It's also made up of nitrogen, argon, and carbon dioxide. It's not different than what you'd measure at sea level.
But your own citation here says that because each layer of the Earth's atmosphere has a different density, each layer is its own, meaning that they're separate homogeneous mixtures based on density, right?
But how do you know that they're referring to the density gradient within the troposphere? How do you know that?
How do you know it? All they mention is density, and we just established that the density of the air at the top of Mount Everest and at sea level are different densities.
Because they said specifically the different layers of the atmosphere. So what would they be referring to if they said that? If it was not the different layers of the atmosphere, well, they didn't say the different layers within the density gradient. Well, they did not say that.
They're making a distinction based on density. So they're saying if they have different density, they're not the same. They're their own separate homogeneous mixtures. That's how I read this. It seems pretty clear.
And are the different layers in the atmosphere not different densities?
Yeah, we just established that at the top of Mount Everest and at sea level, they're different densities, meaning they're different.
Exactly. So they're referring to the different layers in the atmosphere. They're not referring to the density gradient. They're referring to the different layers in the atmosphere.
But they're specifically mentioning density. I don't know.
Density applies to the different layers in the atmosphere.
Okay, well, I guess we'll have to agree to disagree on the interpretation of this citation, but if density is a factor in determining what is a homogeneous mixture or not, I would say just based on the effects of them alone.
Perhaps if I provide you with a more...
The atmosphere at the top of Mount Everest clearly has different properties than the air at sea level, such as the ability to support plant life, and that kind of thing, right? You wouldn't take air from the top of Mount Everest and exchange it for air at sea level and have the same outcome, whatever your application would be.
No, because they're different concentrations, but that doesn't mean that they're not made of the same compounds. You're thinking that because they're different concentrations, that means that they're different compounds. No, it's a homogeneous mixture.
Okay, if that's how you mean it, then they have the same elements in it. Then that's okay. I think we're on the same page then. So.
Okay, so can I get back to the point that I was trying to make to Lemonbird earlier? I asked Lemonbird if the atmosphere is a homogeneous mixture, why do we have a density gradient? Because if the density gradient is based on the dense gases arranging themselves below the less dense gases, Why is the mixture homogeneous, and why do we have a gradient?
Well, obviously, air molecules have kinetic energy, but they can only go so far before they settle. The thing that makes them settle would be the background medium, like the egg in the water, the ether, that decides where things settle when they run out of energy. That's the column that, vibrates the molecules into place wherever they are in the column.
No, Lemonbird. The only logical conclusion to that would be that gases have weight, and because they have weight, they arrange themselves according to their weight, right? So in the atmosphere...
That's hypothetical, you're saying.
But the thing
so in
is...
the atmosphere... In the atmosphere, because mass attracts mass, the concentration of gases is going to be largest closer to sea level. And as you get higher up, since there's less of an attraction towards the Earth, there's going to be less gases. There's going to be less concentration until it gets to a low pressure system.
But if masses attracted masses, the air masses would be attracted to each other. So philosophically, even that is problematic. And it appears that you're coming from this paradigm where the only thing that causes objects to move is a push and a pull, like this gravimetric center or whatever the heck you're talking about. What about vibration? If everything's in vibration, then stuff can simply vibrate into place using sound and frequency. And then, like a cymatic plate, you could put salt on that little cymatic sound plate and watch things vibrate into place based off of the frequency alone. Perhaps there is a background frequency within the ether itself, making everything take its proper place.
To answer your question, the gas molecules aren't attracted to each other because gravity is proportional to weight. And the largest mass that we know of is the Earth. So everything is going to be attracted to Earth. Therefore, all mass is going to be attracted to Earth. So the force between those molecules of gas is not strong enough. It's always going to be overcome by the larger mass.
But just because the Earth is bigger doesn't mean that it has sufficient force. There are very powerful lasers that could, cut through the air and probably cut through the Earth. Sound, frequency, weight itself appears to be this varying activity, this pressure against a scale that changes, an activity that changes based off of the forces going in and out of the substance that you're putting on the scale. Some substances, like air, are so ethereal, you can't even get them to interact with the scale and give you weight unless you put them inside something else that allows that interaction to take place. So as far as I can tell, weight at best is an activity, a changing activity that is not constant enough to throw into this gravity whatever.
Well, mass attracting mass is the only logical conclusion as to why things fall to the ground. Your explanation of relative density has a problem. Consider this. Let's take two objects that have the same density. They have the same mass per unit of volume. And let's put them on a pivot balance. You're going to notice that the heavier object is going to skew more towards that direction, right? It's going to be off balance. So if it was only density that was causing things to fall to the ground, why is it that when we increase the weight between two objects that have the same mass per unit of volume, we notice that one exerts a larger force? That's because it's more than that. Density is just part and parcel of gravity. You're trying to extrapolate it and look at it separately, and that doesn't work.
Well, you could just explain this with the Cheerios and the milk fallacy. The Cheerios are in this white milk that I'm akening to the ether in this pained analogy. You run the spoon between the Cheerios and they appear to be attracted to each other, gravimetrically even. So the question is the gravity in these massive Cheerios pulling stuff? And or is there a substance in space, aka the ether, flowing between them differently, taking stuff in its tow?
I have a Cheerio issue here. If I take 3 Cheerios, put them in a bowl of milk, and take a magnet, I can move them around the bowl with the magnet. They're fortified with iron, so they're attracted to magnets. So, and I took a contract out on the Ether Bunny, and it's going to get whacked next time it's seen in public anywhere.
Well, that
I've got to be wearing bullet vests.
right into science near you.
I'm going to try the Cheerios.
Weight is medium dependent.
Be my guest.
Yeah.
Put a few Cheerios in a bowl of milk and get a magnet, and you can draw them all around the bowl wherever you want. Any fortified cereal that'll float for you. Fortified means they put iron filings in it.
So, can I ask a clarifying question of Babs before you guys continue? So when you said if you put two weights, one that's heavier and one that's lighter, on a torsion balance, the fact that it doesn't hang evenly, that it doesn't even out on both sides, is evidence of what?
Right. It's evidence that there's more. There's something else that's acting upon those two objects other than just density. Because if it was only density, wouldn't you expect those two objects of the same density to balance on the torsion balance? And they don't. You see that the heavier object exerts a larger force.
Yeah, because it weighs more. That doesn't mean mass attracts mass, right? It weighs more. There's another variable in there.
So if it weighs more, does that mean that it's denser than the other object?
No, it doesn't mean that it's denser. It means it's literally more mass, right? Why would you expect?
So it's not density then. Yeah, there you go. So it's not density then, Brandon.
They'll still both fall through the medium, right?
Yeah, but that just proves my point, Brandon. That it's not just density that's making that happen. Density is part of what we're observing, but it's also mass that's causing that to happen. So when we increase the mass, we notice a difference, right?
The up and down is that created by mass? No, I don't think so. The up and down movement within the medium, I don't think has anything to do with how much mass an object has. That has to do with density. Well, when I hold something out into, we'll just say the atmosphere, and I let it go, the thing that determines if it goes up or down is its density relative to the medium that it's in, right?
Right. And if you heard what I said before, I'm not denying that density and buoyancy are part and parcel of gravity. But when you extrapolate density or relative density and look at it separately and ignore that weight is also a factor in that equation, that doesn't work.
But who's ignoring?
For that same reason, that when you increase the volume...
You're conflating two things. No one is ignoring that things can be heavier than other objects and they won't balance out on a scale. Why would you expect them to? Why would that falsify relative density?
Why are things heavy, Brandon? Is it not a function of weight?
Yeah.
And weight is a function of gravity. There you go.
No, it's not.
It's a combination
you're
of
adding
things
that
going
last
in and
part.
out of the object.
You just seem to be saying that weight is a function of gravity. Why does it need to be? It's a function of how much mass there is in there and its relative density to the medium that it's in.
Because if it was only density that was causing that to happen, then we wouldn't see we wouldn't notice that objects of the same density exert different forces when we increase their volumes. We wouldn't notice that.
Sure we would. Why wouldn't
we? If it was only density.
Of course we would. Things can still weigh more. The objects can still weigh more than other objects. I don't know why that would falsify
because density
being the determining
isn't
force.
a force. Density is not a force.
Okay, I got you. No, I'm not saying it is a force, but it is the reason things either rise or fall within the medium that they're in. Can we agree on that?
It's part and parcel of the gravity equation.
But
it's not.
I know
it's not unique on its own.
So, have you bought the whole gravity equation, the whole universal law of gravitation?
Just because it's part and parcel of gravity.
Hold on, guys. Let me work this out with him. But have you bought that whole thing, the whole universal law of gravitation, Babs?
Okay, listen. The only reason that I bought into this is because this can't work on flat Earth. No one has shown me that yet. So until someone shows me that, then yeah, I've bought into it.
But we can show you that. Why can't the force be coming from the mass itself? Why does it need an outside force?
The force is coming from mass.
Exactly, but it doesn't have anything to do with it being attracted to other mass. Why do you need that?
It absolutely does.
Why? Why do you need that?
Because it's been demonstrated in Cavendish.
I would argue that that is not what has been demonstrated, and certainly not to the extent that it's applied to the heliocentric model.
And also, there are other ways even to interpret Cavendish. The Cavendish interpretation is not the only one available. All of the electromagnetic fields were not isolated in that experiment from, the barn, from Cavendish, from whatever.
Exactly.
And there are other explanations even with that.
And they never isolated an independent variable in that, or in that experiment for sure, the Cavendish one. I don't know. I just don't see the utility in this mass attracting mass unless you're then trying to apply it to the celestial objects. We certainly don't need it on Earth.
Because in the example I gave you, you're only increasing the mass. You're not increasing the density.
Yeah, you're increasing
that
the
doesn't
amount.
work with
You're
only
increasing
density.
the amount of mass there. Hence, you're increasing the amount of weight. The weight comes from the object itself and presents itself according to the object's density relative to the medium in which it is suspended.
Right. So the only logical conclusion to get from that is that things fall down because of relative density and weight, not just because of relative density.
Well, I'll agree with you on that, but we don't need an outside force. We don't need mass to attract mass for that to happen. That's an explanation that isn't required.
And when you make the mass bigger, you're also increasing the interaction with the field too. So even there's another interpretation available even with mass. You make the object bigger and it's interacting with the field around it even more. So, I mean, there's even different ways that we could explore even that.
Right. So if mass doesn't attract mass, why do the lead balls, why does the torsion beam balance thing move in the Cavendish experiment? Why does that happen if mass doesn't attract mass?
Wind, electromagnetic fields, other interpretations.
Well, there was never an independent variable that was isolated, so we don't know.
Right. Yeah, there could be. Right. So there is an intangible variable called gravity. Okay. All we're doing, Babs, is suggesting that there is another intangible variable that either is electromagnetic or something else that we don't know. Right? So
why does it have to be something that you don't know when we have evidence to prove what it is?
Because mass doesn't always attract mass. We have magnets that repel each other. What even counts as a mass? The definition of mass is very changing and very arbitrary. One time this will be a mass. Now the air can be a mass itself. Then all of a sudden it's lumped in with the air and the rock and the lava, which act totally differently. Totally arbitrary. And without containment like a barrier, you can't even justify that all of these different things are one mass anyway.
Dark matter is a mass.
Lead balls aren't magnetic. And Payge is here right now. I thought you were busy, Payge. Why are you here right now?
I am. I came to say sorry to Brandon for you misinterpreting what day it was for me and asking me on Tuesday morning if I wanted to chat with you on a Tuesday or a Wednesday. And I said, yeah, well, a Wednesday would be better.
No apology necessary at all, Payge.
I told him to go and check with you, Brandon, and come back and let me know. Because what he wanted was for me not to have my cheerleaders in chat. So I said, okay, come to Emma's. I'll have a chat with you there. Oh, no, I can't come to Emma's. They hate me there. I'll get muted. So, okay, we'll check with Brandon if we can have a one-on-one chat on his show. Okay, I'll do that. Comes like, yeah, that's fine. Said, okay. What I expect from you in that chat, though, is more than words. I don't want to see citations. I want to see a practical demonstration of you creating pressure without containment. That was the deal. I said, I will show you demonstrations of pressure being contained. From my end, I will demonstrate physically what I say has to happen. I expect you to demonstrate it physically as well. So that's why I just assumed, because he's asking me on a Tuesday morning for a Tuesday or a Wednesday, so that automatically put me into the next week. And I thought, okay, well, I'll give him enough time to, get his little clips together or whatever to show me what he's talking about. And then I get up this morning and I'm like, what the fuck? What the hell's going on?
Yeah, it was a misunderstanding. I have no problem with that.
Yeah,
I don't understand.
It was just a misunderstanding.
It was a misunderstanding, but the thing is, I don't understand why you need to prepare for me, though. I can bring a demonstration for you. I can give you everything you want, right? I can meet that end of the deal, but you don't have to prepare for me. This isn't going to be hostile. We're just having a discussion page, so we could have even done this today, But it's all good. I understand that.
For you.
No, you don't. You don't need to
I
prepare for
can literally
me.
pull up a demonstration of gas pressure next to a vacuum with the membrane and the membrane being taken away and it equalizing it. I could pull that up for you now. What I was asking from you, and why I said to you, I won't bother talking to you if all you've got are words on a page. I said you must show me you creating and maintaining pressure, manipulating the cause of your effect. If all you're going to do is repeat to me what I learned in school, I don't want to hear it, mate. I'm looking for actual physical proof of the claims they make.
And did I not tell you that I was going to give you that? I told you that. And you did.
It now I can take half an hour now to let you explain.
Let's not do it right now. No, because you said that you needed to prepare, so let's do it next week. You prepare, then we'll do it next week, and I'll have everything you're looking for.
You're the one that's making a positive claim. I don't need to prepare. I was giving you time to prepare your clips and stuff.
Oh, you were giving me time, right? That's why you chickened out today. Sure.
How did I chicken out when I'm here right now? You asked me on a Tuesday morning show if I would talk to you on a Tuesday
why are you being
or a Wednesday.
Hold on, Paige.
That immediately put me into the following week because it was Tuesday that day.
Okay,
what
Babs,
the fuck's wrong with you?
Babs, why are you being a dick right now? Okay, 2 minutes ago, you gave Paige the benefit of the doubt and said it was miscommunication. And now you're accusing her of chickening out. So which is
chickening out when I'm actually here talking? So that makes no sense. But anyway,
which is it?
Because I'm getting. If you haven't noticed, I'm getting slagged off too. If you're not paying attention, so that's why I'm being a dick right now.
I haven't heard anybody slag you off while I've been here. But I got told. I came in. I stopped doing what I was doing. I wasn't even in this show this morning. Haven't been in the chat. I came in stopped what I was doing and came in here because I was told you were slagging me off for not being in here because you fucked up the time zones and didn't know what day it was.
Yeah, I didn't realize how big the time zone was. You guys are way ahead in the future and shit. And I told you, I specified that it was going to be tomorrow. So how could you not know what I was talking about?
When did you
I told you it was going to be
tomorrow?
I did. Have I not? I've been talking to you for a really long time now, Paige.
And every time you spoke to me, it was only ever the day said. You never said like the date or said tomorrow, the word tomorrow.
You're right. I could have been more specific about it. Yeah.
Yeah, you could have. Because think about it for me. I'm sitting there on a Tuesday morning and you say to me, what's better, a Tuesday or a Wednesday? And so immediately that puts me into the following week because it's already Tuesday. So
but how's I supposed to know it's Thursday where you're at right now? How am I supposed to know that?
You know she's in Australia, right?
Yeah, you've got to be kidding me.
In Australia.
You don't know I'm an Aussie? You don't know that Australia is like one of the first
I don't live in
the sunrise?
I don't live in Australia. Do you live in America? Do you know everything that's going on right now in America? No, you don't.
I know what day it is there, though. I always know it's nighttime for you when it's morning for me.
Well, my bad for not knowing what time it is everywhere in the world. My bad.
Thank you for saying it was your bad and not mine. So please don't slag me off at the beginning of the show like you did, saying that it was my fault because you didn't know what day it was. That's all.
No, I was just mad because I was just mad because the way you were acting like it was a big deal, and I just wanted to talk to you. You know, you said that you weren't prepared.
No, dude, look. I'm quite happy to release all the messages that have gone back and forth between you and I. It seems to me you're the only one that made a big deal out of this, telling me I was being hostile and what have you. Oh, you're gonna just be hostile and mute me and blah blah blah. And I'm like, we haven't even spoken yet. You don't even know me. You don't know anything about. You've never spoken to me in private. You don't know what kind of a person I am. Yet you've made all these accusations. And I'm sitting back here going, what the fuck stories has this guy made up in his head? Like, what the hell's going on?
Well, you don't know me either, Paige, and you get all your info about me from the people that you talk to.
I haven't made a decision
rather
about
than
you.
getting it from me.
I'm giving you... But I didn't say to you in your messages, I think you're going to behave like this and I think you're going to act like this. Did I? Like you did to me.
Well, I told you that because I was worried, and I didn't want you to feel like it was going to be hostile.
Why were you worried if it was no big deal?
Because I've watched how you talk to people, and I just didn't want it.
It's a big deal.
I didn't want you to feel uncomfortable, like it was hostile or anything. That's why I felt the need to do that.
It's always hostile with ballers.
I'm not a baller. I'm not a baller. What are you talking about? I'm not a baller.
Yeah, well, you could have fooled me. But anyway.
No, you're a globehead.
I expect that from, talking to people who have a different view on something. I expect passion. I expect somebody. If you believe something, if you're arguing for a standpoint, then I expect you to be passionate about it and show some emotion.
If you're a real truther, you're a real member of the truth community, wouldn't you admire people that have a difference of opinion? No. So why don't you admire me because I'm not just parroting all this bullshit? Why don't you admire me for that? Because I'm different.
Assuming I don't. Why are you just assuming how I feel about you?
Because you do the same shit. Because you do the same shit that all these other dudes do to me. You call me a baller and you just assume bullshit about me without getting to know me.
No, I'm saying that you seem like a baller to me because of the arguments you present. I've never said anything about you personally, like, in your personal life. I'm talking about in this argument, the things that you present are the same things the ballers present. So what am I supposed to think? If you want me to think something different about you, then behave differently.
Right, that's why you need to talk to me, Paige, and know what my standpoint is, rather than getting your information from other people.
That's what... I don't know anything about you, dude. I didn't even know who you were in chat the other day. Like, I didn't even know who I was.
Well, you know who I am now. You know who I am now.
And that's why I was happy to come and talk to you. But you've gotten your knickers all in a knot and gotten into such a hurry about getting on here. You've gotten Brandon all in a hurry about some debate that wasn't even a debate. It was just you wanted me away from my cheerleaders so that you could teach me something. And I said, okay, well, you better have some practical demonstration of it then. Otherwise, you're just yanking my chain. You said you would have. So where is it?
Well, we'll talk about that next week when you don't have your cheerleaders with you.
More freaking procrastination. What are you going to do? Pull your wanker for a week and just come back and get more bullshit? Come on, guy, grow up,
I didn't postpone this shit. Get the fuck out of here.
Kitty icon sniffing Snow White.
I didn't postpone it either, dude. You asked me for a Tuesday or a Wednesday, and it's Thursday today. So I haven't postponed it either.
Yeah,
this
you
is what
did.
I'm talking about. You got your knickers in a knot, got mixed up about what day it was, asked me on a Tuesday if I wanted to talk to you on a Tuesday or a Wednesday, and then wonder why I think it was you meant the next week. Like, of course I did. You've asked me on a Tuesday.
Can we get back to Flat Earth, folks?
Yeah,
you got your knickers in or not? Let's get back to Flat Earth.
I think that we've established that Payge did. It was not Paige's fault.
Brandon, look,
And
yeah, this guy can go and get fucked. Like, honestly, if he's still going to say, after saying that it's no big deal, saying, yes, it was his misunderstanding, but then still turning around and getting angry and saying it's me in the wrong, well, no, you can get fucked, Chris.
I second the motion. Go get effed.
all right, guys. It's not really not a big deal that Payge got the
No, it
day
shouldn't have
wrong.
been.
Even if it was on the thumbnail and everything, I don't care.
I
We're
got
gonna
the day
figure
wrong.
out
No,
something else
he
to
got
talk
the day
about.
wrong.
Yeah, it doesn't even matter.
Who said this was
You're
a
right,
big
Payge.
deal? Or
It's
who
not.
said this was a big deal or this was rushed or anything? Nobody said that other than you.
Why was I being told? Why was I being told I was getting slagged off? Do I have to actually go back and listen to the start of the show?
No, you
and
were
find out what
talking
you said
shit.
about me?
Listen to me, Payge. Listen, Chris.
did slag me
No.
off.
Babs is talking shit. He's just talking shit.
Yeah,
That's what he does.
He did slag me off.
Yes, he's talking shit. He's
So
trying
not
to.
really very fair. Hey, Brandon, when he fucked up, asked me to talk to him on a Tuesday or a Wednesday, on a Tuesday, on the show, on a Tuesday. Why would I have ever thought he meant right then?
Yeah, don't
Or the next
even
day.
worry about it. Don't worry about it. Not your fault. No one thinks it's your
I'm not.
fault
I'm.
at all.
He does.
Yeah, but who cares? He's
And
just trying to get you
obviously
riled
do,
up,
because
Paige.
you just said that I misunderstood the day. So obviously there's going to be a lot of people who think it was my fault.
No, come
now.
on, Paige. That's not how I meant it. I don't think it's your fault at all.
Okay.
It's just a
Yeah, all right.
misunderstanding.
It's not my fault. Sorry.
I'm not
it's
saying
Yeah,
no one
I
thinks
already
it's
said
your
it was a
fault.
misunderstanding, guys. Come on now. I already said it was a
Then stop saying
misunderstanding.
I chickened out and I postponed and all that shit. Well, then don't keep speaking out of both sides of your mouth and saying, yeah, I misunderstood, and then saying, oh,
All
but
right,
you
guys.
chickened out.
Let's move on. Let's move on.
Fork tongue much?
Let's move on. So,
shout out to
You
Mark
just had to throw that in there, did you?
all right, you guys done? You guys over?
Well, it
Come on.
is fork tongue. It's speaking both things at once.
Let me
That's
do-
the
let-
definition
I'm
of
getting
it.
All right,
slagged-
let me
I'm
move
getting
on
slagged
here.
off
Let me
all
move
day.
on here. So,
It's all good.
while we're clearing the dirty laundry, there is something I've been meaning to ask you about, Babs. I was in Jem's Sunday show one day, and I saw a comment that you made kind of caught my eye. And they were watching a clip from, I think, either this show or Ranty show, and you made the comment, these guys have an IQ of 70 combined to the other ballers in there. What exactly did you mean by that? Were you talking about this show, the people on this panel, or was this a misunderstanding on my part?
Yes, I was talking about the people on this show because I was upset about what happened the first time I came on here. But then we did talk about that afterwards, and then I understood that wasn't your fault. You know, that happened to me when I was on here. So a lot of my responses to you guys has been emotional. So yeah, I'm not going to back away from that. I did say that. I did call all you guys morons and idiots.
So is that what you really think, that we all have a combined IQ of 70, or were you just talking shit because you were angry?
You just explained that.
I just explained that I was talking
no one
shit
asked you.
because I was pissed off.
Shut the fuck up.
Well, wait, hold on, Brandon.
I think you guys might have a combined IQ of 70 if you got to ask that question after he
I think
explained it.
you should shut the fuck up. So go ahead and answer, Babs.
I just did. Yeah, I did say that because I was emotional. I don't think you all have an IQ of 70. No.
Huh. Okay. Glad we cleared that up.
Just a throwaway comment.
Right. And don't try to act like you guys don't talk shit when you get pissed off, because you do. You're not angels. You don't have halos on your head. Get the fuck out of here.
Just trying to understand where you're coming from, Babs. That's all.
Honestly, I've left this show, you know, getting in a heated argument with like Right to Hand or something, and been like, those guys are idiots over there. You know what I mean?
Uh-huh.
Yeah. So your feelings.
Oh, wait, hold on. Let's get this straight. Right to Hand does have an IQ of 70. He's an idiot.
All right. Anyway, so now that that's behind us, now that everybody's happy and loves each other, let's talk about some flat Earth shit.
Kosho. Oh, my bad. Go ahead.
No, go ahead.
We got Kosho. Tell me about gas. Does gas move randomly in all directions?
You got gas, man?
This gas. Say we had a
Oh,
container of
sure.
helium, all the same temperature. Is it all moving? Is the gas moving out in all this in random directions, randomly?
Do you remember what I said to you about an hour ago?
Yeah, they for like an hour and a half they spent on that.
I was getting interrupted, but I was the only one who gave you a succinct explanation. I feel like you should.
Yeah, but your explanation is doublespeak, though.
How?
You can't say it's moving randomly in all directions, and there's.
I never said it was moving randomly in all directions.
So you don't think gas moves randomly?
No, I was trying to say to you, but I got interrupted by somebody in there, so I stopped.
Hey, Jeremy, he thinks it moves in all directions and then free falls at the same time.
Just like I just did just now. But what I was saying to you was that that's a general statement about the collection of molecules. But in truth, they're not moving in random directions. They all have they all have a distinct. They all have a specific direction they're going to be going into, and that's going to depend on the last interaction it just had. So they're going to bounce off some object, and that's going to influence the direction they're going. And then there's going to be a downward vector that's also going to influence the direction it's going. And the scenario I gave you was
Isn't that random?
A mosh pit on a semi truck that's accelerating. So that
So you
mosh
don't
pit
think-
can all be pushing each other in all different directions, but they're all also going to be influenced by the acceleration.
So you don't think gas moves randomly in all directions?
That is random in Kosho. I'm
Listen
so
to what I
sorry,
just-
honey,
listen to
but
what I
you
just
literally
stated
have
there.
no idea which way they're going to move. It's dependent on, right? What? Whatever it's going to hit next. So it's random.
The first thing that I said, Jeremy, was I don't agree that they're moving in random directions. And then I explicitly stated how they're moving and what influences how they move. Right?
Yeah, that's fine.
There shouldn't be questions about whether I think it's random or not, or how I think that's random. I'm not saying that they're random.
That's fine. I mean, mainstream science thinks that the gases are moving randomly in all directions. But if you want to be, go
I
against
hate
them,
having to
I'm fine
repeat
with
myself
that.
whenever I was so explicit. I said that that's a
Hey, shout out to B-Ball for Life, who says, please Google relative density. Maybe later. How do you know that I haven't done it before, B-Ball? And Nap Snaps, $2. It's all Payge's fault. Trollface. Haha. Ah, shit. I should read that when I don't have it muted.
But
so you would say that's
in actuality, each one of those people are moving in a very specific direction, probably depending on the direction that they're going, maybe the way they were pushed.
According to Kosho's gas mosh pit, gas is free fall in all directions. So, thanks, Kosho.
Well, that was some serious doublespeak right there, like almost lawyer-like. Should be
yeah.
written down.
So sorry.
Clear as the bell, just as simple as it could be, y'all. Come on now.
So if somebody came up to you,
Well, you know I love you to death, but that was completely doublespeak, and I'll
Hey,
call you
Stacey,
out.
go ahead and point out what
I'm so
doublespeak
sorry,
was.
but that was. You literally
Point
said,
out
I'm
the
not
two
saying
things
it's
that were
random, but then you pointed out how random it was.
Hey,
I
I'll say
understand that
this.
you think
I
that each
don't
molecule
want
has
anybody
a
to get this
specific
wrong.
way that it's moving.
I never once said that they were random. I did not
So
say
if
that.
somebody were to-
I said
if somebody were to
specifically that
say
they're
that-
not random. I said
So
that the
somebody were to-
collection, if you were collectively talking about the group of them, because you couldn't talk about them specifically, if you're talking about the collection of them, then you might use that word. But if you're talking about what they're actually doing, they're not moving in random. They're not moving in a random direction. Their movements are specifically going to be determined by the interactions they're having.
Jeremy.
So if
Right,
somebody
so that's
came up to you-
random. It's random that interaction is going to happen next. Is that correct, though, or is it specifically already designed and knows which way
I'm
and
not
direction
saying. I'm
it's going to
seriously
go?
not saying that. So that's not a doublespeak. If I'm not saying that, and you guys are the only ones saying that, then I'm not. It's not doublespeak.
So fine. You're saying gas doesn't move randomly in all directions.
Yeah, I said it. Yeah, exactly. I said that if anybody
Right.
says that, they're talking in a
Right.
general sense of the collection of gases. They're not talking about
Well, I
any
mean, that's-
specific. They're not talking about how the gases are moving themselves, because it'd be wrong to say the gas is just moving randomly. It's not moving randomly.
So can you predict where those gases are going to go every time they hit something else, or
yeah,
is it
Kosho,
random?
you mean like a fart, right, Kosho?
Jeremy, what's the relevance of gas to flat Earth?
Sorry,
A
what's
fart
the what?
A fart
is the-
moves in a mosh pit. There we go.
What's the relevance of the question to flat Earth about the
Well,
way
I just want
gas
to point
moves?
out the doubles. I just want to point out the double speak that they use when they say, because I mean, Kosho is the only one. Everyone else says gas moves randomly in all directions.
Right.
However, they also say that there's a bias downwards. That's not random anymore. So they're saying they do move random and they don't move random at the same time.
So it's nothing to do
My
with the
question to
shape of the
Kosho
Earth
is then,
hang on,
if
folks.
a gas molecule is rising up, which way is it going to go, Kosho?
What's the relevance of the way gas moves, whether it's up or down, to the shape of the Earth?
He's saying that gases hold hands, is what he's saying.
But what's
I don't
the
know. We
relevance
talk
to
about
what?
gas
Well-
pressure in here. They were about to
'Cause
have
they
a whole
use
debate on gas
gravity.
pressure.
There
as-
is some relevance when it comes to their model of how the atmosphere supposedly moves with the rotating Earth. In my
So
opinion,
you're stepping into
And
their
the density
model.
gradient.
You step into their model to try and dismantle it. But what we need to do is to stay on our flat Earth and say the Earth presents itself as flat and motionless. And all this pontificating about gas pressure has nothing to do with our position. It's their position. And I'm fed up with the conversation. It sounds like it's a Quantum Arrays and Nathan Oakley show. The Earth presents
Well, I
itself.
was trying to point. My whole
The-
point was I'm trying to point out their double speak and their cognitive dissonance.
Yeah, but this isn't grassroots flat Earth, though. It's pontificating about science, and all we have is this to and fro. Let's get back to real flat Earth basics rather than trying to argue with what the globe model believes to what we have, and we have a solid argument that the Earth presents itself as flat and motionless.
well, I'm
hear
happy to
that,
talk
yeah,
about that, Mark. If you've got a subject that you want to bring up or whatever, we talk about all kinds of different things on here.
Yeah, and I know we do, and we go backwards and forwards. There's an awful lot of personalities get involved with it as well. This density equilibrium was an expression I believe that Eric Dubé first came up with, and it has nothing to do with the shape of the Earth. And yet the amount of effort and arguing that we've put forward on this density gradient. Another thing, when Nathan starts off with his housekeeping questions, they're all an argument to the negative. Is there any evidence of?
Yeah.
Well, there may not be, but that doesn't mean to say it's false. Evidence may present itself.
Well, that's interesting. Because I've often wondered what the purpose of arguing about whether there is a density gradient at all has and what relevance that has to the flat Earth. Who cares if there's a density gradient? I don't understand why that is an important subject in regards to the shape of the Earth. Can anybody explain to me why I should care if there's a density gradient?
I absolutely agree with you, and there's a lot
Because
of
it affects how far you can see horizontally.
That's a good reason, but as far as that's going to happen on any model, right? Is somebody putting forward an argument that this density gradient falsifies a flat Earth or proves something? What is the argument, and why are we so concerned about it?
Well,
it's a red
well,
herring.
Brendan, I think from a glober's perspective, the density gradient is evidence of the atmosphere being in hydrostatic equilibrium due to gravity.
So what? It doesn't tell us anything about the shape of the Earth.
You know what hydrostatic means?
Hydrostatic. Well, hydro is liquid, and static means stationary.
Stationary, yeah. How equilibrium, what it settles out to be without disturbance.
I think if we dug into that, we'd dig into multiple layers of assumptions that would go back to your model of gravity. And I'm sorry, but you may say as a result of our model of gravity, the atmosphere has a density gradient. That is not the only thing. Your model is not the only outcome of a density gradient. It doesn't falsify anything.
Pressure gradient. But what's another?
Whatever.
What else creates a pressure gradient other than acceleration?
Who cares?
Well, I mean, somebody asked why it's important on the shape of the Earth. If there's a
How about
pressure
temperature?
gradient,
A dynamic system.
gradient? There's a pressure gradient.
Yeah, a
there's
dynamic
acceleration.
system would cause a gradient.
When you stack a bunch of stuff on top of each other, does that cause a pressure gradient?
Absolutely.
Yeah, that's exactly what happens.
Okay, then why can't stuff be stacked on top of each other? Why can it only be stacked on top of each other on a globe?
It's on top of each other. That's the whole point.
Okay.
They're stacked on top of each other. There's a downward force. That downward force is due to the mass and the mass of the atmosphere, the mass of the weight, the air above it, and above that, it creates a heavier weight, which creates a heavier pressure down below. So these
Why
things
can't
have,
it be the same on a
things
flat
have
Earth?
consequences.
What does that?
So hold on. Do you see what he just did? He just brought it back to their model of gravity, the mass attracting mass to the center of the Earth. That's what he brought it back to.
Causing
That's what basically it comes down to. I wanted to
down could
tell
just be
both
down.
before.
Yeah.
It's all about gravity.
So things go
That's
down.
why they cling to that.
In any system that causes things to go down, then you would have a pressure gradient, correct?
Yeah.
The thing is, explain why things are going down, why they have weight.
But just
Wait.
Okay, that's fair enough. But answer my question: if we could explain why things go down, that would be enough to say, well, that's why there's a pressure gradient.
Yeah, it would.
It's just caused by things going down. It's not caused by
no,
mass attracting mass. It's not caused by things being attracted to the center of the Earth. It's not caused by gravity. It's caused by things going down.
No. If you could explain why they go down, then you can attribute it to that cause.
No.
Right
No.
If
When you boil it
down,
down,
what you asked.
the pressure gradient is caused by things going down.
Because of what?
That's what you're attempting to
wanna know
answer,
what,
and that's
so,
where
yeah.
you're connecting the dots and saying it can only be this. But
But
at the
Brandon,
end of the
but
day,
doesn't
anything
everybody
that's going to
agree?
cause things to go down is going to
You're
cause a
your head
pressure
in the
gradient.
sand and forgetting that what's going down
But even if we say,
is the
even if we
mass.
say yes, okay, gravity,
Proportionate to the mass.
they still can't prove that going down is to the center of a ball. Down could just be down.
Yeah, nobody's saying
Like
that
there's
yet.
no, it doesn't change the shape. Like they can't prove a ball by saying gravity.
Right.
Yeah,
Well, see,
you're
that's
missing,
what
you're
math.
missing, you're missing a whole bunch
No,
of
that's
parts
where you're
before we even get
mistaken.
there.
That's why they need gravity.
Nobody
because
has
in
even
their
stated that
model,
yet.
everything conforms to a ball in space.
Yeah, nobody stated that except
That's
for
where
you
the
guys.
magic comes in,
Yeah, but
gentlemen. That's what it's
we
You
all
guys
could
are
say
saying-
gravity
Alright.
makes things go down, not to the center of the
Nobody
ball.
else has stated that besides you guys, right?
No, that's your religion. That's why
Right,
you need
and you're telling me
gravity.
my religion. Is what
All
you're
right.
You
doing.
can't let
Instead of
go
me
of
telling
gravity
you,
because
instead of
gravity
me,
makes
instead
all
of
those
me telling
magic
you why I
balls in
brought
the
that up.
sky, right? All those magic planets are formed by gravity,
Right.
condensing matter. No, isn't
So
that what it is?
what you need
You need
is
that.
what you need is you need the weight. The weight is attributed to from the mass. So the mass determines the weight, right?
I have a
So
question.
if you don't have these consequences, then you don't have this. You don't have any
But what
explanation.
pulls all that
You
gas
just
together
sucked us
in
back
space?
into your model
What
again.
pulls all that mass together in space in your fantasy La La Land story? If you don't have gravity, right? How are all those things going to form those magic balls in the sky, like Venus and Jupiter? That's why they need gravity. That's what it's all about. They can't let go of this.
Okay, so this pressure gradient argument is all about gravity. So I don't think we should be out there denying that there's a pressure gradient. Is there an argument that there isn't a pressure gradient?
Nobody makes that argument. No.
No, the argument is who's got the best explanation for it as to why there is one. But Kosho, I have a question that just came to my mind. The atmosphere, the air that is close to the ground, let's say we'll say 10 meters or whatever. There is a molecule of oxygen. Okay, would you be comfortable with that? It's somewhere where I'm at right now. There's a molecule of oxygen, and it's where it's at that point because of your model of gravity. Is that correct?
Make your point, sir.
Okay, can you answer my question, please?
Well, I was making a statement before I got interrupted. I'm not really in the mood to follow down your path, so I'd rather you just get to your point.
My point has to do with your answering a question so that I can continue on with
You're
asking.
if there's oxygen molecules down here. That's your question. Why don't you get to your point, man?
Why don't you settle down, bro? I'm just asking. I'm trying to understand where you're coming from. Okay, so now if we go up 200 meters, is there another molecule of oxygen at that level?
Now you're asking me if there's oxygen up there.
It's
Right? Why
not
don't you just assume what my answer is and then get to your point?
It's amazing to me that you guys cannot.
You're asking me if there's oxygen down here and oxygen up there. The answer is yes. You know that. So just get to your point.
Okay, are they the same molecular mass?
An oxygen molecule? Is that what you're asking? Are they
Yeah,
identical? They have the same properties? Yeah, they should if they're the same
Okay,
isotope.
so
Why
then
not?
why is there one 200 meters up?
Why is there one 200 meter up? There's probably one 5,000 meters up. Like why?
Why isn't it down at the same spot as the one that's 10 meters?
Why is there water at the bottom of the ocean and water at the top?
No.
Because it's all over.
Travis, because the atmosphere is homogeneous, Travis. Because the atmosphere is homogeneous. That's why.
Okay, listen very carefully. If you are arguing that the molecule of oxygen that has an atomic weight is existing at 10 meters because gravity is holding it there, then another molecule of oxygen 200 meters should not be at 200 meters. It should be at the same spot as the other one at 10 meters. There's no reason.
That's a fantastic argument. How does that work?
Travis.
How does that work with the ocean, buddy? The bottom of the ocean is 15,000 psi at the bottom of the ocean.
All the water.
15 psi at the top. There's water droplets at the bottom. There's water droplets at the top.
Kosho, it's okay. I know why you're misdirecting right now, Kosho, but let's bring it back.
No, you're making non-point. I'm trying to show you why your point makes no sense whatsoever, right? We have the ocean is completely made of water molecules. There's water molecules at the bottom, water molecules at the top, right? There's 15,000 psi at the bottom. There's 15 psi at the top. Okay, so your point is irrelevant. There's oxygen all over the atmosphere. It has nothing to do with the pressure gradient.
There's oxygen all over the atmosphere. It has nothing to do with the pressure gradient. Is that what you just said?
Correct. I just said the pressure gradient is due to the weight of the amount of gas above it, not the type of gas.
And the concentration of those gases is highest at sea level because the force of gravity is strongest at sea level, and it depreciates with altitude. That's why you have less concentration the higher up you go.
Okay. So again, I'm just trying to understand your model, your model, Babs, right? Okay, so gravity is now affecting the mass and pressure at ground level, but is it a collective mass? Because it's not like individual oxygen molecules, hydrogen molecules, nitrogen molecules, argon, whatever, right? It's in mass, like all of them together, not because my point is that if you have an object at ground level molecule, and then you have another molecule that's 200 meters up, it doesn't make sense to me why you would have a different gradient there. They should all be at the same level. That's all I'm saying.
You just
answered your own question, Travis. The atmosphere is homogeneous. That's why you find the same mixture of gases with altitude.
Okay, I'm not talking about the atmosphere being homogeneous in its elemental structure. That's not what I'm talking about.
You're saying that if the oxygen's identical, they should all be at the same altitude because they should be affected the exact same way.
Yeah.
This is not how material works. When you're carrying a sack of anything, if you have a sack of rice, a sack of candy, a sack of pretzels, all the pretzels are not going to be all at the same level. There's going to be pressure at the bottom, and there's going to be less pressure at the top, and there's going to be pretzels in the bag.
Travis seems to think that gases work the same way that solids do, that they arrange themselves according to density.
Pretty sure,
that's not
Babs.
how it works.
Babs, pretty sure. I said I just thought of this, and I'm asking a question. You cool with that?
Yeah, I'm cool with that.
Okay. Interesting.
Can I answer? Well, wait, hold on, Brandon. Let me answer your question. You wanted to know why the gradient matters, why it's important.
Yeah.
Because you can't have a density gradient without gravity. So how do you have a density gradient on a flat Earth with a dome over it? How do you have that?
Temperature.
Well, without gravity, objects still have mass, right?
Yeah, they do. Yeah.
And the more mass they have within a medium, let's say oxygen, the heavier they are, correct?
Yeah.
No.
Okay, and then within a medium, denser objects will fall down if they're more dense than the medium and rise if they're less dense. So they will pile on top of each other according to their density in any system where things are ordered up and down, right?
Correct.
Okay. Then
But hold on. Let me just say this. Hold on. Let me just say this. We can assume that the density gradient is a function of gravity because gravity is strongest at sea level. So therefore, there's going to be a higher concentration of gases at sea level than there would be at higher altitudes because of gravity. But if you consider this on a flat Earth with a dome over it, how can a homogeneous mixture have a density gradient if there's no force causing that to happen?
Well, there is a force. Hold on, let me answer the question. Hold on, let me answer the question. There is a force. There is a force. It comes from the matter itself.
No.
Yes.
What is that force?
It's the matter.
If it's not gravity, then what is that force?
It doesn't need to be external to the matter. It doesn't need to be external to the objects.
Gravity is not external to the object. It's intrinsic to matter and anything that has mass.
Again, that's false because you're conflating an observation to it instead of proving that that's the cause.
So is everything not made of matter? And does everything not have mass?
So pressure is what drives the mediums all around us. It's all pressure driven. Pressure overrides.
How does pressure form the density gradient?
Because the molecule is heated by temperature. So usually a denser material is colder than hot matter. But we're talking gases versus, you're talking about two different states of matter or three different states of matter, right? So they all act, gases act independent of solid mass. There's no direct downward force. They act based solely on pressure. That's it.
You're not making sense because you're not explaining what creates the pressure. The pressure is
temperature creates the pressure. So we know air expands with increased temperature. So with air expanding, listen, gentlemen, don't interrupt me. With the air expanding causing by the temperature differential, we cause pressure. This is a fact. We live in we don't live in a congealed system. We live in a dynamic system. Anisotropic, inhomogeneous. That's where we live, and it's all driven by pressure and temperature.
It's not correct.
Temperature changes causes pressure differentials. This is caused by the sun. The sun is the driver of it all.
So let me clarify. Hold on, before you respond, let me clarify with Data what he's saying, because I have a question to clarify what he's saying. Are you saying that, and then you can go, Kosho. Are you saying that the pressure, the pressure gradient is created by the unequal temperature at the surface of the Earth compared to higher up, or how exactly does that work? What is the mechanism? The sun heats things up and there's more pressure at the surface, or how does this work?
So pressure is caused by pressures because we know how air works. It expands on temperature. So you heat up that temperature, it's going to cause a differential. That differential molecule is going to find its equilibrium. It's always in a state of equilibrium. This is where it is, seeking its equilibrium. This is a natural law. What's driving the natural law to seek equilibrium is temperature differential. This is a byproduct of the sun. We don't control the sun. We can't turn it off. It's a byproduct of a natural process. That temperature differential is causing the gases to find their equilibrium.
Why is atmospheric pressure?
It takes you a long time to say that, man. It's a simple refutal, man. In Colorado, there's 11 psi.
You don't account for pressure. You don't account for pressure.
11 psi in Colorado.
You claim it's gravity, dude.
It's 11 psi in Colorado, dude. You say fucking one thing that takes 20 minutes to say, right? I'm gonna say one thing that takes 5 seconds. Let me get to the end of it. In Colorado, it's 11 psi. All right, it's a lot higher, a lot lower pressure, and than it is down below.
5 seconds are up.
It's always true that it's
again.
Your 5 seconds are up.
Gases are made at the lower.
Well,
gases are made at the lower level.
We can't have a conversation if both sides aren't able to respond. Were you done, Kosho?
Fuck no. When I'm done, I'm not talking anymore.
Yeah, but you said you were only going to take. You said you were only going to take 5 seconds.
It doesn't matter, dude. It doesn't matter,
It
dude.
does. You said 5 seconds, Kosho. Come on now.
Talk amongst yourselves.
All right.
Come
so
on.
you don't want to repeat. I get it. So I was interested in this conversation, but I think the point is, I think the point it was Why is there a different temperature in Colorado at altitude versus lower altitude if it's driven by temperature? Why is there this even pressure gradient from sea level to, you know, the top of Mount Everest? Why is it so consistent if it's driven by temperature?
Well, you have to look at the process of gases where they're made. The most amount of gases are made at the surface. The higher you go, the less they're made at that area. Colorado is making as much gases as it was at the surface, and it would probably have the same pressure, but it's not producing the same. It's not producing the same amount of gases up there because it's at higher elevation, right?
That's not even close to what the point was. You had said a second ago that
you're trying to say why was the
data? You gotta let him respond. You gotta let him
you don't have
talk.
to get it wrong this time.
Yeah, he's claiming that he says, why is there less pressure up top if it's due to temperature? That's what his question was.
Pressures reduced to the temperature,
right?
Let's hear it. Can we hear what he has to say? Go ahead.
See, the pressures were due to the temperatures. You said that that's what creates the pressures, is the different temperatures. However, in places where there's less pressure, sometimes there's more temperature. Okay? So it doesn't work that way. It doesn't work that when there's where it's warmer, there's higher pressures. It doesn't work this way.
Well, yeah, because
We're
like the equator would be the highest pressure zone. Is that true? And the Antarctica would be the lowest pressure?
Yes.
Is that how it is?
And we don't see.
Data, what do you base this model of how the pressure gradient is created? Out of curiosity.
Well, I have to assume, like for instance, the way I've derived my understanding is taking a vat of water at a certain temperature and then varying the temperatures from water. One's hot, one's cold, and then putting it inside of the vat of this one. Like for instance, if you had a vat of water at 10 degrees, then you had one vial of water that was at 2 degrees and one was at plus 15 degrees Celsius. This is all in Celsius. I'm sorry, don't be Fahrenheit. And if you did that, you would see that the hotter liquid would rise to the top and the colder liquid would sink down to the bottom. This is driven by pressure. It's driven by temperature. It's driven by temperature, which causes a pressure differential inside the vat. So if fluids are finding a location to go to based on its search for equilibrium, it would be driven by pressure. So why would I think there'd be a magical force out there driving the gas to go downward? It would be driven by pressure. That's why you have different elevations of different gradients in different areas, because of the pressure around those cities. If they're different highs and lows, you're going to have a different pressure, a different gradient there. The higher you go, less gases are being made at the surface. The point is it's all driven by pressure. There's no magic force pushing it down. It's the force above pushing the other molecules down, right? The weight of the atmosphere is pushing everything down, they say. Well, how do you change that? Produce less gases at the bottom of the earth, right?
That's confusing me because in Colorado there's lots of trees, and as far as I know, the type of trees that there are, say, in the mountains, evergreens and whatnot, those also produce oxygen, don't they?
Awesome. The fact is that if most gases are produced at the ground level, this is just what vegetation does. You're talking about, you're trying to say, well, gravity must be holding the atmosphere down because if I go higher, therefore there's less atmosphere, therefore gravity's holding down. That's what I hear for your argument.
Well, I wouldn't use the word gravity though, Data. I would use the mass or the weight is causing it to go down just like anything else. Because if you removed all that gas, there would theoretically be, nothing, right? Empty space.
So here's the thing: you can still have the amount of gas be at that area, whether it's hot or cold. It's just there's a difference between high and low volume of it. That's why you have pressure changes before a storm, right? The pressure changes around us. We can actually feel those pressure changes.
Well, that is true.
Right?
There are pressure changes due to temperature for sure.
So that affects the gas.
Yeah.
So it would change the pressure of the gas in that location, the temperature differential. If you have a high front or a low front coming in, it will change the pressure of that area, therefore changing the volume of gas in that vicinity. right? So it's independent again. It doesn't think of gravity. It doesn't have any preference of gravity. It's going to find its equilibrium. That's its main purpose. How does it do it? Well, it's an energy exchange again, from hot to cold. Well, hot to cold has a differential. It has a pushing pressure.
If I could just respond just real quick to what I think Kosho and Babs brought up with grains of rice or water. To me, that's a false equivalency. Water is a liquid. Grains of rice are solid. You're not going to have a grain of rice working its way down to the bottom of the bag. So I don't think that those work in terms of trying to say that whatever happens with water, it's what happens with the atmosphere. It's what happens with a grain of a bag of rice. So that's my response to it.
If the only way you can prove gas has a downward vector force is by removing the atmosphere around it and then containing the gas inside a balloon and go, hey, look, the balloon is falling downward, then you know, damn Skippy, you remove that balloon, you remove the vacuum, that gas, that helium will fill the available space. The balloon is confining that helium. So I don't know why we're using these ad hoc explanations or demonstrations to mislead people, but gases don't have a downward vector force. They may settle based on equilibrium, but that again is the driving force. Entropy or equilibrium is the driving force, not gravity.
Can you show anything that you're saying? Can you back anything you're saying up with any kind of experiment or reference?
As soon as you do that for the atmosphere sticking to the Earth.
Hold on. I want to respond to that right there. I want to respond to that. Can you back that up with any sort of experiment? Listen, if you're going to insist on the claim that gravity causes the pressure gradient, then you should be willing to explain how you should be willing to explain how you removed gravity from the experiment so that you could observe the pressure gradient going away in the absence of gravity. If you can't show that, then you have not done science. You have assumed.
I'm talking about what data's saying. I didn't say anything about what I'm saying. I'm talking about.
So how I derived my idea, again, I told you what the experiment is you can do. Take a vat of water, put it at 10 degrees, or 15 degrees Celsius, whatever, then put hot water at 30 degrees in a little vial, put another vial of cold water, put it in the vat, and you will see the reaction of the pressure differential caused by temperature difference. You will see the reaction. You will see the cold water being pushed down by the water around it, okay? Right, the water around it is expanded, has more pressure than the cold water. They're pushing it down on it, right? Because it's only a little vial of cold water.
I don't think that's equivalent to the atmosphere.
So listen, the point is that I can raise and lower water based on temperature difference. How is it raising and lowering? Based on that pressure differential, which I'm creating by increasing or lowering the temperature, not gravity.
What keeps the water in the bath, though?
The container.
So, Howard, where's your experiment that demonstrates that the atmosphere is connected to the Earth?
No, it's all about mass attracting mass, Travis. That's
But that's that experiment. I just showed you that vat.
No,
that test does not show mass attracting mass.
You didn't show me anything.
You're saying mass attracting mass. Listen, you're saying mass attracting mass is an involuntary inherent process of natural phenomenon. It's not, because I can control the direction of these water molecules and I control the direction of gas based on a temperature differential, not on measuring gravity or claiming gravity. I literally can change the velocity or the pressure.
Can you wave your hand? Can you wave your hand over it and make the water come out of the tube?
Listen.
So what kind of question is that? Is that a real question?
I don't know.
Or is that a real question? Is that a real question you asked me?
What's keeping the water in the tube?
So the containment.
Okay. When you put your tap on, which way does the water go? When you release your faucet, does it go up, down?
Oh, why don't you tell me?
Obviously, it goes down, doesn't it? What makes it go down into the container?
So what is it making it going down? You tell me.
I don't know.
What's it falling through?
Well,
There you
okay,
go.
okay. I want to avoid using the word gravity because of the whole debate of gravity and orbital mechanics and all that. But just that description of why things go down because they are heavier, I'm going to use the word gravity. Gravity with a small g.
Which weighs more, hot air or cold air?
Cold air weighs.
Obfuscation.
Cold air weighs more. It actually does.
It
Well, I mean, it depends on the depends on the size. It's equal
happens?
volume.
What happens if you heat up that air? Then it doesn't weigh as much.
Well, we're talking about volume, aren't we? Yeah, it's a bit of a diversion there, but cold.
Is it?
Yeah,
All right, can I ask a question real quick? It just came to us. Sorry. So, if we have an ice cube frozen, does it weigh more? Is it more dense than that same volume of water in a glass, but it's liquid?
Water has a special a property that it actually expands when it goes down to.
Okay, but I don't think that. Yeah, I get that. But my point is that. So your question to me, I went to just simply a molecule of air, right? So the cold air is more dense, right? That's what we say. Okay, so let's break it down atomistically. Let's go to the very smallest particle and just say an atom of oxygen, right? So if you bring down the temperature for one atom of oxygen, does it get more dense?
Not
right?
not one molecule, no.
Okay, great. So, okay, hold on now, but I mean, I think that we should be able to start going, this is interesting, right? So let's keep adding these molecules or whatever. So now we have 100 billion of them, and then you make them all the same temperature, and then all of a sudden you got more density?
0 plus 0 is 0.
Density has to do with volume, doesn't it? So you've increased your volume.
I'm just asking a question that came to mind.
As you chill water, the molecules slow down. They arrange themselves closer together, and they become a more dense volume.
I think that's correct, right?
Yeah, and volume has to do with the unit per square inch, unit per square container.
Mass per. Is it density? Is that what you said?
Volume.
Volume is just the amount of space it's taken up.
Per what?
Per whatever. Man, what are you talking about? That's the amount of space it's taken up. It's not per anything.
What do you mean? But what space are you talking about? Like, is it a?
Volume is describing an amount of space.
How do you describe space in three-dimensional space? Come on.
Volume.
Length, width, breadth.
That's what he's saying. He's saying that those two things are the same thing. If you're trying to describe something in 3D that is space, you're describing its volume. That's what he's saying, I think.
Well, that's what he's trying to say, but
So if you draw a 3D,
obviously
draw a
volume
cube,
is calculated. How do you calculate volume?
Don't you need boundaries to calculate volume?
Yep. How do you calculate volume? Go.
Of course.
There's a bunch of different ways you can calculate volume.
How do you calculate
You
volume
have
without?
to have boundaries, though. Otherwise,
How do you calculate volume without? How do you calculate volume without a measurement of size? How do you do that?
Size, you could have its mass and its density. You could have.
But how do you do that if there's no how do you do that if there's no confinement? If there's no standard? How do you measure a volume of anything if you don't put a parameter on it?
Well, the point is, my point is, you're talking about heating water up and it floating. As you warm water, it becomes less dense. That's why it floats to the top. The cooler water will be at the bottom.
It has nothing to do with gravity. It has nothing to do with gravity. That's my point.
Without gravity, it has.
You're affecting the direction of a molecule, and you're causing a pressure differential based on temperature. Not
but it don't come out of the dang bottle.
So in my controlled state,
Yes, it does, Howard. Yes, it does.
In my controlled state, I have a dependent and independent variable in this observation. It's a controlled experiment because there's a dependent variable and an independent variable here. There is no reason to think of gravity.
What's funny is they've lit flames on parabolic flights and in orbit and things like that, and but heat doesn't behave that way when you're not under.
So I just demonstrated an example you can do that you don't have to think of gravity and why the water reacts the way it does. You think of the temperature and the volume of that molecule or the size, what temperature it is, and you can actually calculate the velocity. It doesn't have any correlation to do with gravity, nothing.
Yeah, and or contained pressure. So when you're talking about lighting a flame on the ISS, right? That is a container. I could be right. And there's also a
pressure is Earth.
Static pressure in there, which would make flames react quite similar
It's
to
the same
how
pressure as on Earth.
any pressure.
Yeah.
Mm-hmm.
Oh, it's the parabolic flight.
So it proves nothing. Yeah. Proves nothing.
They don't change the pressure on parabolic flights. It's the same pressure as on Earth. The pressure is not what's making it do that.
Exactly. Yeah.
So I don't think I've heard anything that would prove the shape of the Earth in regards to this pressure gradient. Personally, I heard some people assuming that it was due to their model of gravity, the reason that we have a pressure gradient, but I also heard another hypothesis, and I'm not an expert in this subject. It doesn't interest me that much. So I appreciate the discussion and the back and forth. But I don't think this is proof for the shape of the Earth one way or the other.
Well, here's the thing. If they're claiming that the atmosphere is held down by gravity, giving it its weight, then all of a sudden the sun comes along and changes the differential pressure of it, and all of a sudden it's not the same PSI. So again, it's another what? Gravity is just not strong enough argument.
And last time I tried to get to the bottom of that whole thing about the pressure gradient, I never got a chance to finish what I was saying. But there's actually consequences to the way in which we understand the pressure gradient. And what's
okay, listen, man. Listen, are you following my?
Hold on, Data. You could let him talk. I know it can be painful, but please continue, Kosho.
Yeah, there's a pressure gradient, not because of the heat, but because of the weight of the atmosphere above it, and the weight is caused and influenced by the amount of mass that it has. So the mass is the main decider of what this weight is going to be, what this downward force is going to do, and without an explanation for what causes that, you can say all sorts of things. But the way we make sense of it is by the apparent attraction of mass to other masses, and this has consequences on the shape of the Earth.
Here's the thing, though. You say mass attracting mass. Can you be more specific? Because you're claiming that it's an all-vector direction, but that's not observed in reality. In reality, there's only one downward vector force across the whole Earth. There's not one at 45 degrees. There's one. It's just straight down.
Never worked with vectors before, but when you have multiple vectors, you don't end up.
But there isn't. There's only
with those vectors to end up with just one vector.
There's only one vector force that you're claiming to, and that is gravity. And the phenomenon you're observing is things dropping. So please tell me how that one observation equates for all mass and all molecules to attract each other.
I feel like I just was telling you that.
Oh, tell me again. I missed that.
Understanding that multiple vectors, when let's say I'm a math student, for instance, and I have multiple vectors, and I want to figure out I want to figure out how this object is going to be moving. It has so many different vectors, maybe force vectors, gravity vectors, being applied to it. So what you end up doing is you combine them together, and you find out what's the single vector that's going to be affecting this. And
okay, I'm going to repeat my question again, Kosho. I don't think you heard it. You're observing one downward vector force. Okay, how are you conflating that to omnidirectional vector forces and equating it to one force, downward force? Give an example. Hold on, I'll give you an example.
Can you be, man? I literally was
Cavendish gravity is the observation of the oscillation of a horizontal bar with weights attached to it, conflating the horizontal rotation, determining the weight of the Earth. Okay, this is basically the concept. I'm going to watch an oscillation of a horizontal bar. I'm going to calculate the distance between the two masses in a shed from a telescope half a mile down the road. Right? This is the concept. Now I'm asking you. Now I'm asking you. Why are you conflating? Why are you conflating? What
I was just
evidence
answering
do
the
you
question
have?
that you were just asked.
What
And I
evidence
was
do you
telling you
have?
specifically about how you get multiple vectors and turn it into one vector.
How do you? Where do you see it? Where do you see these multiple vectors? Where do you see these multiple vectors? Where do you see these multiple vectors, bro?
Fluid dynamics.
Fluid dynamics. Okay, give me a description, please.
Things moving in different directions, but with a primary, a dominant direction.
With a dominant direction. Okay, so gases don't have a dominant direction; they're inhomogeneous.
Kosho is
so
giving
listen.
you a concise.
Gravity is not affecting this process. So where's entropy and gravity? Where do they meet?
If you would let Kosho finish what he was saying, he could answer your question.
I asked him where
I was
he saw.
explicitly telling you how you
Let me clarify it. Let me clarify it. I asked you where you saw these vector forces. Buddy spoke up, which was you,
that
saying
was
fluid dynamics. You interrupted Kosho and said fluid dynamics, and I asked you to explain, and then you told me to listen to Kosho. Kosho, go ahead, explain.
Yeah,
listen, dipshit. If you have multiple vectors, like if you have something like a mass apparently attracting mass, and you're saying all the mass all over Earth is attracting mass, you're going to have a bunch of different vectors. And you're not going to end up with a bunch of different vectors. You're not going to end up with a bunch of different vectors. Dude, don't do it. Don't do it. You're not going to end up with a bunch of different vectors because you're not a retard. Maybe you are, but I'm not. So I'm not going to end up with a bunch of different vectors. I'm going to
all you have is an ad hom.
And I'm going to combine them.
All you have is an ad hom. All you have is an ad hom. Again, where do you observe? Where do you observe these vector forces?
Let him finish,
idiot. Why? Another ad hom.
The problem here is Kosho's not answering where do you see specific words. Where do you see that, Kosho? Not what it says.
That's not the original question.
That was always the original question. That's why you peeked up.
It said fluid dynamics. I answered that in the question. You just talk over me, dude.
No, you didn't, Kosho.
Yeah. Don't talk over me this time and see if you hear it.
You did it.
See if you hear it this time. See if you hear it this time.
You're running like a little turkey.
See if you can hear it.
You're just running like a little turkey. Gobble, gobble.
If you can hear it this time. There's vectors coming from every single mass.
Where do you see that? Where do you see that?
Where do you see it?
Where do you see that?
Where
do you see that?
There's no point trying to talk to you monkeys, dude. You guys don't. Yeah, you
Again,
guys do this.
It's your philosophy that you think you come from a monkey. It's your philosophy that thinks you come from evolution, bro, not us.
Brandon,
you're the one who thinks you come from a monkey. So listen again. Where do you see it, Kosho? Real simple now. Try again.
Okay. Kosho called us monkeys. I have a question for Left Lane. If we can kind of just
hold on. No. Don't divert like that. Hold on. So
I just got called a monkey. I'm gonna go see if Left Lane can just have a little.
In a minute, you can.
I'm not talking about it.
So just hold on just a second. Thank you. Hold on.
Left Lane.
Hold on. All right, Kosho, do you think you got a chance to answer the question in uninterrupted? They're asking you, where can you see it? Did you answer that? Take as much time as you need to provide an answer. Please, no one interrupt so we can hear the fucking answer for the last time.
Where do you see a vector? Are you asking where the vectors are coming from? Because if you're asking where do you see a vector, then you're retarded. If you're asking where the vectors
Stop it.
You don't see
You're
vectors.
derailing.
You don't see vectors, Stacy. Just like you don't see two whenever you look at two birds. You see there's one bird and another bird. You don't see the number two in the sky.
Can I ask it to you then? You'll be honest to me,
Hold on.
He doesn't see vectors. Hold on. He just said he doesn't see vectors, right? He doesn't see vectors, he said, but yet he claimed vectors go in all directions and attract the masses. Come on, brother. Where do you see it?
I'm done with this. It's like talking. It's like what Babs said about it's less than 70, dude. There's no way to answer questions when you ask them in the most retarded way, dude.
So let me ask a clarifying question. So Data, when you ask where do you see the vector, what are you referring to? Are you saying where do you see the motion?
He's claiming that all masses attract each other, and there's omni-vector forces, is what I'm understanding, and I'm asking where he sees them. That's it. Very simple.
Where do you see the actual movement?
The vector force, because what we do observe in reality is a downward vector force of matter, physical matter, right? Like solid matter, right? So he's saying that because I see the solid matter drop. Therefore, all mass attracts mass. I'm asking where his omni-mass attraction, where does he see it to rationalize that belief? Because gas doesn't operate that way. It has no attraction to gravity. It's inhomogeneous, and it's isotropic. It is fluid on the matter of heat transfer, energy transfer. It has nothing to do with gravity.
Yeah, he was trying to answer and you wouldn't let him.
He had many times to answer. He had many times to answer.
You asked
He
me
was
where do you
not
see
answering.
vectors? That's what you asked me. Okay. Now, if you ask me where do you see mass attracting mass,
Where do you see it?
How do you know that? How do you know there are multiple vectors?
Because in the Cavendish experiment has shown that.
It shows it in a horizontal.
It
shows a horizontal vector.
Exactly. That's a different vector. That's exactly
That's not multiple. That's not multiple.
Yeah, there's a downward vector in that same test.
That's 2.
Yeah, right. Yes,
Just say
multiple.
2.
Where's the omni, bro? Like gas. How gas goes in all directions and fills the available space.
Maybe they can answer it.
Fluid dynamic.
They can answer it.
Keywords, guys. Tell us about fluid dynamics and tell us how, please.
I have a question about fluid dynamics. Go ahead, left lane, though. I think you.
No, everybody knows that fluid dynamic stuff, just moving around and blah blah blah. Y'all can't get an answer to it. You can't learn anything.
Great
you want to
answer.
No, I'm not interested in talking. I'm not interested.
Answer. You are about 2 cue balls short of a pool table, aren't you?
FED, I have a question for
That's a parent ball.
I have a question for left lane.
Who plays pool with 2 cue balls?
That's the whole point, idiot.
Yeah, that makes no sense.
You Globers are playing with 3 cue balls and you're all nuts.
You said that you're 2 cue balls short of a pool table. That's what you just said.
That's exactly right, buddy.
Left lane.
You only need one.
Hey, left lane. Hey, brother.
You think about it, Kel, because like you know how to think.
Left
I think
lane, what's
that makes
going on?
sense about how long you think about
Quick
it, man.
question. Gee whiz, you guys.
It's not supposed to make sense, just like your globe model.
You can bat this fucking ping pong ball around all day long. Left lane. I'm gonna make this short and simple. Just answer. I'm not dumbing you down or anything. Okay, you've heard of Mount Everest, right? Left lane, yes or no? We've all heard of it.
I'm not interested in talking to you, Aaron.
Okay, so Mount Everest is also, connected to the Earth, right? Okay, the answer would be yes. So Mount Everest is part of the mass of the Earth, right? The mass you're talking about that attracts things, right? How come things aren't attracted to the mass of the Earth on Mount Everest like gases? Even though it's part of the Earth, right? It's part of that mass.
What? What?
Okay.
So repeat that last part. Are you asking why things aren't attracted to Mount Everest?
He's saying if gravity is attracted
I'm
to
asking
mass.
why they're not attracted to the surface of the Earth, because Mount Everest is part of the surface of the Earth, right?
Okay.
The mass of the Earth that they keep talking about, that big ass mass.
Yeah.
Yeah. Okay, how come all these gases aren't attracted to that portion of the surface of the Earth?
Well, I'll answer because I don't think it's that, no offense, but that great of a question. There are gases around Mount Everest.
14.7 psi?
No, but there's gases.
Why not? Yeah. Oh, no, there are, Brandon. I agree with you, but why not 14.7 psi? Just like a surface of the Earth. Doesn't matter if you go up over a hill and down a hill. You're still, you're still going over the surface of this mass that they want to believe in, right?
Yeah, I get it.
So why isn't it 14.7 everywhere?
On the surface of the Earth. Yeah. Why is it always
Ideally, it's colder up above, so it's probably most likely a blanket of downward
I get temperature plays a big
and
thing.
then you have basically a range. Within that range, the sun works in electromagnetically and heats up the surface of the Earth. All kinds of funky things happen with that, right?
So gravity doesn't
primarily there's a blanket of cold air above
us
that would be pushing down.
Gravity only acts equal at sea level.
So,
man, damn
okay,
it.
well, hold on. This question came to my mind earlier too, and again, this is not my typical field of discussion. So my question is, what is it that measures air pressure at sea level? What do we use? Is it a barometric? Is it a barometer?
It's a vacuum sealed barometer.
Okay,
Use mercury. Yeah, we don't use it anymore.
Okay, so my question then, Kosho, is does air pressure at sea level ever change, or is it always 14.7 always?
Change with the weather and all that, but not by much.
Okay, so it's not gravity. So it's not gravity. If
It is gravity. That was going to be what, because to answer the last question about the coldness and that made no sense, by the way. But about the thing.
So you're saying,
the real answer, it'll answer both those questions at once, is that it makes the most sense, easily, is that due to the weight of the atmosphere, the pressure is created. And you can tell by going up to Mount Everest. Because when something is, like the same thing with the ocean. At the bottom of the ocean, it's 15,000 psi because there's so much water above you.
You're saying
top.
gravity is less at the top of the
No,
mountain.
I'm not saying gravity is less.
It can't pull down those oxygen.
That's not what I'm saying. I would have said that if that's what I'm saying. I just told you. Pressure, then if you are underneath one, you can use, you can measure the pressure in the air by using a barometer.
No, how do you weigh it? We're not talking about, containing things and getting a pressure. How do you weigh an air molecule?
You have to be more specific with your question.
You can only weigh gas in
Okay.
a container.
How
There is no other way.
you weigh a gas?
Well, I was
How
weighing a
is that
gas
not-
2 hours ago. I used a scale.
Yeah, so tell me how you did it.
Page,
Sure,
they have
sure.
gas
I
scales.
poured-
They have
I
gas
poured-
scales. They put a molecule of gas on.
Just let this fuck up. I'm not going to run with
Hey,
this.
and then
Yeah, just
flick
let
it.
Kocho talk, guys. What the fuck?
yeah, come on, go ahead.
I just simply had a scale. I put an empty bottle on the scale, and I produced a gas, and then I poured that gas into the empty bottle, and then I weighed it some more, and the weight was increased.
Right.
What
So
gas was
you had
that?
a container
What gas?
to weigh it.
No, you can only weigh gas.
So
You can only weigh gas
What-
in a container. Absolutely.
Well, I mean, it was an open
Yeah,
bottle.
so-
If I would have just poured it on the scale, it would have been the same thing. If I would have poured water on the scale, I mean, that would have been stupid. But if I had a cup like I did, and I poured water in that cup, that would be smart. A smart way of weighing water. And that's the exact same way I weighed the air. I poured it into an open cup.
What kind of gas were you
couldn't
using,
weigh it without
Kosho?
CO2.
You can't
Okay,
weigh gas
is
without
that gas less excited than the atmosphere itself? Depending on temperature?
Was it colder or hotter than the surrounding air, or it was in a closed container?
Yeah, I didn't use a thermometer. I used a scale just to see its weight. So I'm not sure what's the relevance of the temperature.
Well,
How
I'm
long-
just trying
how long
to
did you
understand how the different
What if-
variables impacted it, but you think it was relatively the same temperature as the other air, right?
Yeah, because I know the density of CO2, I knew that it was going to be more dense in the air, and I know that if you have CO2 and you pour it like from a
You poured
cup
this in
into another
Hold
cup,
on,
it'll-
Aaron,
it'll
hold
warm
on.
back up.
Go ahead.
Sorry.
So you
Pour it from
knew it
one
was
cup to
more
another
dense,
cup.
and then you poured it. Go ahead. Sorry.
From one cup to another cup, yeah.
How long did you let that CO2 sit in your bottle?
A few minutes, I suppose.
So that's interesting. So you're pouring this gas into a cup, an open top cup, Kosho?
That's right.
Okay, and you did see the scale register an increase in weight.
That's right.
So
Brandon,
that would
where did you
that
get
would
the
seem to
container
suggest
pour
to
the
me
stuff out
that
of?
there is some kind of density thing involved where the gas is separating itself at a lower level from the surrounding gas. I don't know. What is the
No,
other
you're right,
explanation
Brandon.
for that?
You're right.
Is there an alternative explanation for how that could, what that effect that Kosho measured could take place?
It reminds me of
Well, what if
an experiment that we did at school when we made iron oxide, or no, sulfur dioxide. That's what we made. We had a little crucible and we put in so many grams of sulfur and so many grams of iron filings, and then we heated it up. Sorry, we weighed it at that point, and then we heated it up to the point where it fused together, and the ingredients became heavier than initially. And so the explanation we were given was that oxygen had united with the sulfur and the
Yes, sir.
iron. And
Exactly.
So the oxygen had some sort of weight added to the initial ingredients. So that's one way that you could measure the weight of oxygen.
Just to be clear, I've never heard of a cup of CO2. I've heard of liquid form CO2. When you compress it enough in a container, you could have liquid form of CO2. But when you open that or expose it to any medium that you're in, it just fucks off. So you're not, Kosho, you did not pour CO2 into a cup, dude. Come on.
You could wait.
Yeah, I'd like to know what did he do? Take a big container of compressed CO2? Like how did you get it out of something into your cup, buddy? How'd you do it?
I used there's lots of ways you can do it. I used baking soda and vinegar. Baking soda and vinegar.
Awesome. And what did you contain that in? You transferred into a cup.
I did contain it. I'd mixed it into a cup, and then I allowed it to mix. And as the gas was produced, I simply poured the cup so I wouldn't let any of the powder or liquid go into the other cup, but only the gas. And I watched
During that chemical reaction, what vector forces did the chemical reaction cause?
I'm not sure how to answer that.
Did it go up or did it go down?
Go up or go down?
I'll take
The
a
ga-
cup
the-
too. That'd be great.
The process of
the gas was created. So when the gas was created,
yeah, did it go upward when the gas was created?
No.
It didn't go up.
Hey, Kosho, that
Then
sounds
how did
scientific. You did this on your kitchen counter, right? Yeah. You know, sounds really scientific. Like how you weighed CO2. Yeah.
It sounds like an interesting experiment to me. I don't know what the problem is with it. I don't know. What do you think it proved to you? What was your conclusion based on that experiment, Kosho?
Well, I mean, I didn't learn anything new when I did it, but I was, I guess I would have verified that gases do indeed have this weight and do have the same properties of all other masses.
When they're in a container.
General.
Where's the video?
You don't need gravity. If it has weight because it's in a container, then we are contained and the weight is weighable because we're in a container.
It's an open cup, so I weighed the cup
Yeah,
before.
it's still a container.
Okay, well, I don't understand.
You can't weigh that weight without the container.
I could have just poured the CO2 on the scale, and it would have given a slight increase, but then it would have, of course,
Maybe so.
further, so.
What did you video it with?
Because we're in a container.
Suppose I could do it again right now without the cup and just use the tray.
Surely you videoed it.
So we're in a container. Is it like a cup?
Did you videotape it, Kosho? Is there a video out there somewhere?
I did. I was uploading it for somebody else, but I'll show you a picture. But it's honestly for somebody else's video, so I can't post a video. But I could show you a picture of. I got pictures of the scale readings and all that.
Yeah, go for it. It'll be interesting to see what we're talking about.
And
Yeah,
if
so
you
what
prove
comes-
what the
Kosho-
containment is, then yeah, I can't tell you that no, it's not a cup because I don't know for sure. You know, that wouldn't be logical to me, but you know, if you're going to ask stupid questions.
Left lane lives in a cup. It's okay.
Well,
Yeah.
Payge, so even if he does use a cup, what does that mean to you? If it's in a container and he can show that the weight increased when he put this gas in the cup and put it back on the scale, what does it matter if it's in the cup or not? I'm just trying to understand where you're coming from.
It proves that gases have weight.
In a container.
No, but Payge is saying
Yeah,
that
but
it's
they
in a
say-
container.
No, in a medium.
Can you guys let Payge answer? Because I'm pretty sure I addressed that question to Payge. Payge, what difference does it make to you if it was in a cup or not?
Because what they're saying is weight is dependent on gravity. And I'm saying no, weight is dependent on the container. We are contained. They can show weight quickly before the gas fucks off somewhere, but to actually have it stay there, they have to put it in a container. But we're already in a container. You don't need gravity. All you need is weight.
So this is more about containment of the gases, but obviously they have to weigh something, right? If it put it in a cup, and then the weight increases on the scale.
Weight of it in the relative, the difference. I don't understand why they need a force to do something.
Anything that has weight applies pressure. Anything that has weight applies pressure.
Yeah, and you say we've got pressure. So what's that got to do with gravity?
It has everything to do with the weight of the atmosphere. And it has nothing to do with a container.
I don't disagree. Well, that's where I disagree. Because we can
But
show
you said
that
you said you don't
containment to
disagree.
create pressure.
But
Sorry?
see, if weight...
No, you don't. You don't need containment to create pressure. That's only when you're considering
that's what you were
gas
physically
pressure, not
demonstrate.
atmospheric pressure.
Right. So that's what you were supposed to physically demonstrate to back your claim.
Right, but I didn't get the opportunity to do that. But we'll do that later on.
Well, do you have a video, a physical demonstration?
I do, yeah.
But see, here's a point. If weight was merely as a result of the environment around you, the medium around you, you would not weigh any more than the force that medium would be on you. Yeah.
Not just because of that. It's
And Howard, back up your
what
claim.
fucking straw
What do you
man
mean
was that
I
you
wouldn't
just built?
weigh more or less, depending on the medium? Right.
Well, it's 14.7 psi atmospheric pressure at sea level. So why do I weigh 200 pounds at sea level?
That's pressure.
Well, because
pressure
that's
and weight.
that's your,
Nothing. You've not said anything about
you're
gravity.
displacing, Howard. You're displacing how much? 210, 240. Gee whiz. You're displacing that much gas. That's all you're doing.
No, I'm
It's very
not.
simple. Now jump in the water, Howard. Jump in the water with the scale below your feet and tell me what the scale says. Okay.
That's irrelevant.
It's medium dependent. Are
That's
you kidding
irrelevant.
me?
Yeah, that destroys my argument. So that's irrelevant.
No, it doesn't destroy my argument. You're obfuscating.
Then answer it. No, you're not. You're talking about weight. And he said it's medium dependent. And you said, no, it's not. So he says, put the scale in the water and stand on. What do you weigh then? And you go, oh, that's irrelevant. Like,
You haven't answered the question. You haven't answered the question of why I weigh 200 pounds.
You're displacing that much atmosphere. Okay, good.
Why do I weigh 200 pounds?
That's how much gas is bouncing off you if you want to go that route, right? If you want to go that route. That's how much gas is bouncing off you. Okay.
Yeah, no, it's not.
Hey, would you have weight if you poured the gas in a cup? If you poured the gas in a cup, would you have weight? Wouldn't you have the same weight on the sides of the cup?
Nope.
Exactly. Why always put the scale on the bottom? Why not the sides? Okay.
Yeah, it's called pressure. Pressure.
That's the point, man.
This is for Babs. Pressure is weighed on all sides of the balloon or whatever container it is. So you don't just pour it and weigh it on a scale. It's going to be pushing on the sides too. You can't show pressure without a container, dipshit.
You can pour gas directly onto a triple beam scale, and it'll measure that the gas has weight.
Yeah, you can blow on it
Put
too.
a scale on the ceiling, and then
And don't call me dipshit, Brian. Don't talk to me like that, you
register a
dickhead.
weight on that scale.
You think so?
Hold on. When the gas falls on the
without a container, because it's.
Wait, hold on.
The gas falls on the scale.
You don't want to show it.
Yo, Brian, don't call me a dipshit, okay? You dickhead.
All right, hold on.
Don't talk to me like
When
that.
the gas falls on the scale, it's not the weight.
Oh, stop
when
being
the
a
gas falls
snowflake,
on the
Chris. God.
When the gas falls on the scale, that's not the weight of the gas. I could throw a baseball at a scale and it's going to read a number. You think the baseball weighs that much?
I think you've just applied a force to that scale. You applied a force to the scale, absolutely.
Yeah, that's what the gas. That's what happened with the gas.
Yeah,
That's not the weight of the gas.
scale is just measuring a force. The force is in this case the weight. If it was just
that's not the weight.
You mean instantaneous momentum?
It's
like a moment. That's it. Yeah,
How can I get a weight on that scale that I've put on the ceiling when I let go of a helium balloon then? If it's gravity, pulling everything down, giving it weight, why can I put a scale on my ceiling, let go of a helium balloon, let the helium balloon hit the scale, and it will read
that's more
weight, quote
It's
unquote.
anti-gravity. It's anti-gravity.
Yeah,
Faye.
anti-gravity. Wow.
No,
Amazing.
I think they call it buoyancy.
Yeah.
So, yeah, gravity's nowhere to be seen.
No, it's everywhere to be seen in a buoyant.
But you're
So you
saying
gotta add a whole
the
nother force.
weight on that scale is because gravity's pulling things down is why something registers a weight on a scale.
Yeah.
Well, no,
Yeah, let me say
I'm
one more
sorry,
thing.
but
Let me say one more thing. So you got the carbon dioxide going down because of gravity, but you got the helium going up because of gravity and buoyancy. See, that's where
Because
your
of
shit falls
gravity.
apart, in my opinion.
The buoyancy is a effect of gravity.
Good point, Brian. Good point, Brian.
Yeah.
Like for instance,
yeah,
if
it's
I,
an
for
effect
instance,
of gravity. But you
for-
can just
for
take
instance-
gravity away
hold
on a
on.
flat Earth. You can
Hold-
take gravity away because you
All
don't
right.
have orbits and shit. We
Hold on.
don't need
I'm trying to respond to what he just said, so give me 1 second, please. Like, when I'm pouring this CO2 in this bottle, in this cup, I'm pouring the CO2 in this cup. It's going to be displacing the air that's in there. The CO2 is going to go to the bottom of the cup, and the air that was in there is going to be displaced above it. This is how buoyancy works. When you have a balloon in the atmosphere, the balloon is being displaced by the heavier air. That's all that's happening.
Yeah.
We know your explanation, but dude, you're adding shit that's unnecessary. You're adding a whole nother equation. Look, the only thing we can determine is how dense the gas is. That determines where it goes. Period. If it's denser than the air around it, it's going to go down. If it's not, it's going to go up. Period. That's all we can demonstrate. That's why gravity's not a force.
Exactly.
But
So when I jump in
you
the
can't
ocean,
demonstrate
Kosho,
changing
when I-
something's
when I-
direction with gravity. You can't manipulate
See,
it and
this is
show
why they
us
had to
that.
eliminate gravity as a force, because basically you're saying if the sun exploded, in your model, if the sun exploded, then Pluto, it would take like 100 years before it flew off, and they had to eliminate that.
Well,
Masters of the
Easy, Brian. Easy, Brian.
That would be 4 hours,
analogous to
not 100
Kosho's
years.
argument about the balloon and shit. If I were to jump into the ocean, right? How come I don't sink to the bottom of the ocean, Kosho? That's analogous to your balloon.
That doesn't
thing
make any
you're
sense,
talking
man.
about, right?
Yeah.
It's analogous to your balloon thing, though, right?
Yeah,
So
because it's
balloons
medium independent. That's why you don't sink. It's got
You
nothing to
floating
do
at the
with
top of
gravity.
the ocean is analogous to the balloon. You know.
All right, guys. Well, I don't think we got to the bottom of that, but interesting stuff. So we're going to go ahead and do final thoughts, call it a night. I got to say it was one of the strangest nights of the show that I've hosted. I don't exactly know why. I can't put my finger on it, but I do think that's true. No offense to anybody, for sure. Let's start off. Brian Leakey, final thoughts.
Yeah, sorry so late, but I just had to jump in. I was listening. Sorry to call you a dipshit, man. I just get frustrated when people make claims that and don't show me. If you got it, I would love to see it. I'd also say that air pushes, it's dependent on its density and the medium it's in is what we see. That's what we see in reality. We can come up with all this other shit. That's fine. I can try to come up with explanations myself. I enjoy doing that, but in reality, what we demonstrate is what medium something's in and what its density is. That's all we need. I don't think we need the force of gravity. They need that to leave the planet. And George explained it nicely. We only need the F equals ma because to explain the weight of stuff on the moon and stuff like that. Here on Earth, we don't really need that equation. It only starts changing when we leave reality. Thank you.
Thank you, Brian. Appreciate that. Chris, Matt, Babs.
Yup, can you hear me?
Yep.
Okay. Yeah. How these kids copy me is insane because I got a lot of my big brain. Now, you don't like me? That's really whack. You only like the guys that tap dance for super chats. And everybody considers me a catastrophe. You disrespected me, the god. That's blasphemy. And you avoided all my shots with your cartwheels because you're all just pussies like Garfield. And that's why you get smoked like cigar fields. I just lay back like this is how God feels.
All right. Thanks, Babs. Appreciate it. Flat Earth Aussie, Jesus. No? Data. Data? No. I see you lighting up, Flat Earth Aussie, but I don't hear anything. Global virus foe.
Yeah, as usual, good show. I like the banter back and forth. Hopefully, we're able to keep it civil so that we can, actually hear each other's answers. And I love all you guys, and I hope we realize we're on the same team eventually. But yeah, I mean, I understand getting frustrated with each other, but yeah, we're all working to try to just figure out this reality.
Thanks, man. Travis.
Yeah, great show, Brandon. Thanks.
Thank you, sir. Jeremy.
Yeah, I just want to say you can't weigh gas without a container, and that's all. Have a good night.
Thanks, Jeremy. Kosho.
All right, I don't want Jeremy to feel left out, so he knows how I feel about him. He's a great guy, so I'm just leaving out of this. But I wanted to say something about two people in here. Brandon, you first of all. I give you a hard time sometimes, but I noticed tonight that you do try to be fair, and I do appreciate that. So I just wanted to say that. I noticed that, so that's cool. And Babs, I just wanted, because I guess some people said they don't know Babs that well or something like that. The first time they met him was last week. But I just want to say that from as long as I've known him, even as FE, it doesn't matter to me. He is kind of one of the most stand-up guys in this conversation. He's always been very honest, and sometimes he gets a lot of hate for that. And I think that a lot of the other flat earthers maybe you can take a second look at him if you got mixed feelings about him or whatever, because he really is he is just really honest about what he sees and believes and that kind of stuff. And I just noticed he gets a lot of hate for that, but that's it.
Thanks, Kosho.
Thank you, Kosho. Howard.
Yes, sir. I would like to mirror what Kosho said about Babs. I've always been impressed with his presentations and his position. And like the gentleman that said we all need to get along, and I agree with that 100%. I like you, Brandon, and I like coming on your show and talking to you guys. Bad's position on the gravity, he's recognizing something, and I'm going to say this: no matter how hard you try and what you try to figure out, you're not going to be able to escape gravity because it's there, and there's no way to deny it. And that's all I got. Thanks, Brandon.
Thank you, Howard. And who's next? Aaron.
So if we were to say that Mount Everest, which is a mass, which is connected to the greater mass called the Earth, right? And so, and that mountain itself is attractive, gravity-wise, like Left Lane was just saying, you can't get away from gravity. Then how come everything gets pulled down to sea level when actually Mount Everest would be the greater force of mass, of the Earth, right? So just a thought I had, and we can ponder it later. Thanks, Brandon and panel.
Interesting question now that I understand what you were getting at. Payge.
Yeah, not being able to deny gravity, that is hilarious. I just want to see it being manipulated, please. I'm so over this. We read it in a book. I was taught this at school. Blah, blah, blah. I want to see you manipulate the cause of your effect. If you can't do that, then you literally have nothing but rhetoric. And the only reason Babs gets any hate is because he won't give his position. So on the baller's side, they think, oh, he believes in gravity, so he's a baller. And on our side, we go, oh, my God, he believes in gravity, so he must be a baller. And then he goes, no, I don't know what the shape of the Earth is. So of course, we're going to be like, what the fuck? If I just don't waste my time, Chris, if you honestly do not have a demonstration of the manipulation of your cause of your effect, don't waste my time, okay? I'll come and talk to you if you do have it. But otherwise, I'm warning you, don't fucking waste my time, please.
Told you multiple times that I have it. You know that.
You know what I'd like to ask, if I don't mind? It's sort of interrupt. I know you were trying to ask me earlier. It's just where gravity first showed up in these experiments.
Hey, Brandon, you're really, really low for me, Brandon.
Can you guys hear me now? There we go. Okay, can you hear me now?
That's it. Yeah.
God dang, Cat is going freaking psychotic. I'm having lots of problems back here tonight, guys. Sorry about that. Okay. Who are we on? Rob Keane. SE Montreal.
Yes, sir. Great show, interesting show. The gas pressure thing, yeah. I got this to say about that. Nobody brought this up, I believe, tonight. Regardless of what model of how you ascribe gas pressure, whatever, layers, pancakes, the main issue that nobody brought up is it's surrounded. There's a ball surrounded by this stuff, this gas. It is spinning at 1,000 miles an hour. It's traveling at 66,000 miles an hour around, you know what? And all these motions, they're traveling at 1.5 million miles an hour. Now, you ask me, I ask you, what mechanism holds this gas to the Earth while it's doing all this? If you can answer that, you have the answer. But so far, I haven't heard anything. Peace out, everybody.
Thanks, Essie. Appreciate that, man. Bob.
I'll just basically reiterate what I said earlier. If you're going to insist that gas pressure is only created due to gravity, like it can only happen because gravity exists, then you need to show in an experiment a removal of gravity so that you can observe the density, or not the density, the layers going away. You have to be able to isolate it and take it away to show that it doesn't happen when that thing is gone. If you can't do that, you're just guessing. You're assuming. You're throwing something out there and saying that it makes sense or that it matches up with what you guessed. Well, that doesn't make it true. You need to show that it can't happen when that thing is gone so that we know that it needs that thing to happen.
Thanks, Bob. Tom Walbrand. No? All right. Anybody I skipped? Cool. Appreciate it, guys. Thanks for joining the panel. Like to hear both sides of the issue. It's not always easy to stay unbiased. Try to give everybody a chance to speak. I do agree, as I'm sitting here thinking about what Mark Doxey said earlier about less arguing about the ball and more talking about what Earth actually is and trying to figure out where we are, etc. I think that he's right. We get distracted with this argument back and forth quite a bit, and I know it's entertaining and it's fun, it passes the time, but we should be focused on trying to figure out where we are, what we are, who we are, all those things that we believe that we don't know. So I agree with Mark.
Right, let me add something real quick. If anyone knows anything that will only work in a straight line, please let us know. Thank you.
All right, that's it. Thanks to the panel for joining tonight. I will be back momentarily to record an after show. Bye. Okay, well, that was a very different show, guys. I don't know what's going on tomorrow. We'll see, but I appreciate you guys watching the show, listening to the show. Thanks for coming in. Thanks for coming in chat. And I hope everybody has a good night. And we'll see you again tomorrow, 5:05 Eastern Standard Time, 10:05 GMT. Until then, see you later.